Hello.
Hello, how's it going?
Good, how are you?
Good. I will be right back. Oh, actually, let's make one breakout room for API help because we're gonna, or at least some people might need to make a Hugging Face API. Um,
Oh, okay, yeah.
yeah, so for that, just in case people need assistance with that, let's make one.
Okay. Are you gonna make it or do you want me to make it?
I can make it and then um we can just go from there.
Okay, yeah, I need to see what my Hugging Face API token is.
All right, I think we can start letting people in.
Okie doke, I will do that.
All right,
Good morning,
welcome
everyone.
everyone. Good morning. Welcome to day 2 of week 3. Today's going to be a long day. We're going to do a deep dive into LangChain. As usual, we will still be using Google Colab, and just things to keep handy. You'd want your OpenAI API key available easily, and you would want, if you already haven't made one, a Hugging Face API key. If not, we will definitely be here to help you create one. And just so you know where to get the Hugging Face API key, you can find it in here if you were to log into Hugging Face. And don't worry if you don't have that key ready quite yet. We'll have a breakout room to help you set that key up. And also, we're not going to be using it extensively. It's more so to kind of show examples using Hugging Face. So if it doesn't quite work out for you, no worries at all. Right, I think there's quite a few of us here. So let's get started, and I'll send the link to the repository again in the chat once more. And I'll start sharing my screen. All right, can everyone see my screen? Sounds good. All right, so here's our repository again. We are looking at week 3, day 2 LangChain deep dive. And as usual, we're gonna click the open in collab button, which will bring us here. As you can see, it's pretty long notebook today, so we won't really have any breakout rooms, but please feel free to unmute yourself or send questions in the chat, and we will definitely stop and answer any questions that you might have. So the first thing you're going to want to do is run this first code chunk. This does take about 2 minutes to run because we are installing a lot of packages. But once that's done, everything should be smooth sailing from there. And while we wait for this to run, it'll take a minute. Does anyone have any questions before we get started on content we've covered so far, content we covered yesterday? Just general LangChain questions about what we'll be talking about today. Happy to answer any of that. Let's give this a couple minutes, and then we should be just fine.
For the Hugging Face token, it has the read and write. Are we just using the read?
Yes, we will be just using the read.
All right.
And just so you all know, you will get an error at the end of all of this running saying it wasn't able to find a distribution for the FAISS package. Don't worry about that. That's all good.
So the keys, just how sensitive are the keys? I mean, it seems like they, the various tools, like they hide it from the screen and that kind of thing. And how should we handle these keys?
So I usually like to use some sort of password manager, although I am pretty bad about using those, but password manager is the way to go. Otherwise, if you're willing to risk it, you can definitely put it in a note somewhere. My OpenAI API key is on a private GitHub repository, which I can just open up and copy from there. So that works too. But yeah, it's pretty. Also, if you were to accidentally put your API keys on, say, a public GitHub repository or anywhere that someone else could possibly access it, OpenAI has a pretty robust system that almost immediately sends you an email saying that your key's been deactivated because they found it online at a public source somewhere. So for the most part, you shouldn't have to worry about that. Raymond, you had a question.
Yeah. Where exactly do we add it as an environmental variable for Windows 10? So we can, so if we're unable to use Collab, we can still just pull it as, create an environmental key with that exact name, assign it to our secret key. Where would we actually do that? Because I was having a little bit of difficulty yesterday. I didn't have compute resources for Google Colab. And I was trying to add it as an environmental variable less, but then it still couldn't detect it.
I am unfamiliar with Windows. Miranda, do you have any tips for that?
Yeah, you should be able to add it the same way. Like if you have a Jupyter notebook open, you can just do this. This exact code will do that. You could go into settings and add the environmental key manually, and I would honestly just Google that. It's a weird process. So either just use this code in a Jupyter notebook or add it manually yourself.
Yeah, I'll just run it in the notebook because I followed the process that I searched. So I can see the key in my environmentals. But, oh yeah, I'll do that. Thank you. But yeah, when I followed the quote unquote standard steps, they face planted.
All right. Okay, so this seems like it has run. You will find 2 errors and you can ignore those. Google Colab just doesn't like some packages sometimes. And so next, we're just going to put in our OpenAI API key. And let me copy that real quick. Paste that in here, hit enter. And that gets us set up for pretty much everything we'll need to do. Okay, so in this notebook, we'll pretty much take a deeper look at almost everything that we talked about yesterday. I think everything except agents, we're leaving that for Friday. But there are, in terms of the biggest components of LangChain, there are models, there are prompts, memory, indexes, and chains. So those are the biggest things apart from agents, and we'll be kind of going deeper into all of those today. So let's first start with models. And there are 3 kinds of models that you'll come across when working with LangChain. One are just simple large language models. They take in a text input and they return a text output. The other is chat models. These can be exactly the same model as well. So, but they're backed by a language model of some kind, like GPT 3.5 Turbo. But the APIs that are used for these models specifically are a little bit more structured than LLMs, and they take in a chat message object as an input, and they return a chat message object as an output. And we'll see some examples of how exactly those are different, but they're very, very similar and almost identical when it comes to using them. And finally, there are text embedding models. These models take in text as an input and return so a vector of floats. And this will be important pretty much every time we're trying to use a external document, and we need to convert those into numeric representations so that we can do some sort of semantic search on them. So as mentioned, so chat models are a subtype of language models in LangChain, and there's a subtle difference, but this is kind of how we would call them. So if I wanted to just use a regular LLM, so I would just do from LangChain LLMs, import OpenAI. So this gives me access to any LLM that OpenAI has. Here I could pass in a model name parameter and call GPT 3.5 Turbo, GPT-4, pretty much any model that OpenAI presents you with. And if I wanted to use OpenAI's chat model, so that would be using the chat OpenAI wrapper. So I'd just do from LangChain chat models, import chat OpenAI. And that pretty much gives me access to the base models that come along with these 2 wrappers. So I'm just gonna run that real quick. and then a simple text-to-text interface. So LLM.predict is how I would use a large language model. And if I just tell it to say hi, it says hi there, and it's preceded by some new line characters. If I were to use the chat model instead, I have to use the predict function in there, and it returns a string saying, hi there, how can I assist you today? So chat models are a little bit more verbose generally, and also the formatting tends to not be awkward. Michael, you have a question?
Yeah, I guess maybe yesterday, I think somebody probably asked that question already. Like in that language model, why it returns 2-character returns again?
I don't exactly know why it does this, but it just seems to format it in a certain way when it's returning stuff from a simple LLM. But that being said, there are ways in LangChain to ensure that that behavior persists or doesn't persist, because you can pass in a parameter in a prompt that kind of parses the output in whatever format you want, and we'll take a look at that as well. But you can change what this output looks like. This could also be a JSON if you wanted it to be. But there's a variety of ways to approach that, and we will go over at least one of those today. So the one way that chat models are slightly different is that they can kind of take in this message object, and these messages can have a variety of sort of users. So you could have the human message, that's the one that the user will likely send, and then you will have something called an AI message, which is likely going to be the response that you get from the model. So to see that, all I have to do is from langchain.schema import human message. So now I'm telling the chat model that this is the human message, and I can just do llm.predict messages, and it'll just be human message content, say hi. And so I will be returned with another message object, which is going to be the AI message, where it'll tell me, okay, hi there, and then additional parameters if there are any. And yeah, it's exactly the same. LLMs can also take in these schemas, but they're designed to work well with chat models. So again, if passing it in, you pass in a human message, you'll get out an AI message. Let me take a look at the chat real quick. There seem to be a lot of questions. Okay. Someone seems to be getting an authentication error, Miranda, if you could take a look at that. Yep. All right. So taking a slightly closer look at LLMs in general. So as said before, you can pass in the model name parameter. And so here I'm just pulling the text ADA01 model. And there are various parameters that can go with a specific model. So these will be model specific, but apparently text ADA has these two parameters, n equals 2 and best of 2. Essentially what this is telling the model is telling it how many completions to generate for each prompt and how many to return. So it's saying, return 2 and generate 2. And again, works exactly the same way. And instead of doing llm.predict as we were doing before, you can also just do a shorthand, just LLM, and then you just give it your prompt, and that'll work as well. You can also pass in multiple prompts if you wanted to. So here I'm passing in a list of prompts. So I'm saying, tell me a joke and tell me a poem. And then I'm also multiplying that by 15. So essentially what that's going to do is it's going to run each of these prompts 15 times. And so if I run that, it'll take a little bit longer. And if I look at the length of the result, I can see that it's 30. So it created 2 for each one of those, and we can take a look at those here. So this is the first one. So why did the chicken cross the road? To get to the other side. That's one of the examples of a joke that it created. And similarly, at the very end of the list, we can see one of the poems that it created. And this is another parameter specific to OpenAI models. So LLM result dot LLM output. So what this will give you is sort of like a summary of how many tokens you're using. So this is good to keep in mind if you're doing a lot of experimentation and might be on a budget. especially if you're working with something like GPT-4, which does tend to be a little bit expensive. You can keep track of how many tokens you're using using the LLM output. Again, we can look at managing usage a little bit more. So you can use the get num tokens function, and you'll be able to pass in a string and just see how many tokens that string is going to be. So tell me a joke breaks up nicely into 4 tokens. And so you can kind of get an idea of how many tokens your prompts are looking like. So if you have constraint limits, if you're using an old version of GPT 3.5 and you want to ensure that your prompts are within your context limit, you can kind of use the get num tokens functionality to figure out how many tokens you're using. This is the next little bit. So this is where we'll use our Hugging Face Hub tokens. So essentially what this is for is you can use open source models with LangChain as well. So essentially you pass in your Hugging Face Hub API token, and you want to ensure that this is a read type of access token and not a write type of access token. And once you've pasted that in there, this is how you would use the Hugging Face Hub to use in open source models. So here I'm going to use the Google Flan T5 model. And so essentially what it needs is a repo ID. So that will usually be the name of the model. And then any model parameters that are specific to that model. So for Flan, temperature is a model parameter that it requires, and max length is a model parameter that it requires. These will be model specific. So depending on what model you're using from Hugging Face, these will change, or they might not exist at all. Just one thing to keep in mind is that not all models on Hugging Face are fully supported yet. Like a simple BERT-based case won't work. They have a list of specific models that they currently support, and it's mostly along the lines of large language models. But any LLM on Hugging Face like Bloom should work with this. And again, so simple, you give it the repo ID, you use the Hugging Face Hub function, you give it the repo ID, any model parameters, and that sets your LLM. And then you do need to pass in a prompt template for this specific model type. Some of them don't require prompt templates, and we'll see prompt templates in more detail in the following section. But essentially, you create this template where it takes in a question and an answer, and you're telling it to think step by step. And you create the prompt template. You say template is equal to the template that you just created. You pass in the input variable. We've seen a little bit of this before. And then you use, this is the, I guess, second time you guys are seeing a chain, but we're using the most basic chain, which is LLM chain. We pass in our prompt and the model, and then we ask it a question: who won the FIFA World Cup in the year 1994? You'll do chain.run and pass in the question, and it will give you an answer that is played every 4 years, and the final answer was Brazil. So it kind of did a step-by-step analysis of the question. We're not going to run this next code chunk just because it wants to download Bloom, and that is a very big model. But essentially, if you wanted to run models locally, and this is the question we got a lot yesterday, is you can't do that. So Hugging Face pipeline is the functionality you're going to want to use for that. For any model on Hugging Face that you want to run locally with LangChain, you just say Hugging Face pipeline from model ID, and then you'll give it, again, this is going to be the repo ID. So like up here, we had Google/Flan. Here we have Big Science /Bloom. You give it the task, which is text generation. In this case, any model parameters that you might need. And that sets the LLM, and essentially what it does, it downloads the entire large language model. So here it did download, 4 gigabytes worth of a model. And again, this model specifically does need a prompt template, very simple, similar prompt template to what we just saw up above. And again, the same thing as before, prompt template, you pass in your template and your variables, you create the chain using LLM chain where you pass in your prompt and your large language model, you ask it a question, and you run the chain to get an answer, and that works fine. It just won't work if you're not using Colab Pro, which I'm not. because you will run out of RAM very, very quickly. So before we move on to chat models, are there any questions? Chris.
Yeah, what does task equals text generation do exactly?
So the Blue model can do multiple things. It's a multimodal type model where it can do text generation, it can do summarization, it can do a variety of different tasks because it's trained to have like different heads on it. So it can do a variety of different tasks. So for this example, specifically, we asked it to do text generation, but this could be replaced with any other task that Bloom is capable of doing.
Got it. Thank you.
Yep. Other questions? All right.
Michael has his hand raised.
Oh, sorry. Yeah, Michael.
Yeah, I have a quick question in terms of when you, what actually happened behind the scene when you do this locally? I would assume that you have to have local storage, vector database, and all so on and so forth, right?
Yeah. Essentially, it's downloading the entire model. So this would, after this point, it would look like just however you would run a model locally. So you're no longer dealing with an API at that point.
So if I do that, I should be able to see on my local files. I see, yeah, I probably can try it, afterwards. But what are the components is going to set up locally? I guess, right?
I don't exactly know what it does in the back end, but it just kind of downloads all the config files for the model. So it will essentially download the model to a folder on your computer and then run it from that folder. So it's sort of like, you exported a random forest model to a pickle file, and now you're running that model off of the pickle file.
So let's just say if I do the search, right? Or the indexing. If I assume we can do the same, then if we load the file, I mean, one of the concern with using the API is that I don't want to, give my data to the remote storage, whatever. So I would assume there will be some kind of local vector database will be created as well.
Yes, you would create a local vector database instead. So instead of using something like Pinecone, which sends your data outwards, you'd use something like Deep Lake or Chroma, which creates locally persistent vector databases.
Yeah. I guess, is that all handled by the Hugging Face pipeline, or I have to just set up myself?
You'll have to set that up yourself, and we'll talk about that today as well.
Okay, got it. Thank you.
Yep. Other questions? All right, moving forward. So chat models in LangChain. So these are going to look very similar to the LLMs, with the minor difference that these models take in chat message objects instead of texts. So again, keeping in mind, LangChain is constantly evolving what these APIs look like. So you're going to want to possibly go and look at the correct code if things tend to break. For example, here you could pass in a name parameter at one point, but now they've changed it to model name, which can be quite annoying. So just if things start to break with simple things like calling a OpenAI bot, just go to the documentation and you'll be able to figure out exactly what they changed. But essentially, again, if I want to call a chat model, I use the chat OpenAI instead of just the OpenAI call. And then I pass in this parameter that says temperature equals 0. So essentially, temperature is a parameter that gives the model some sort of creative flexibility. 0 means that the model will be more precise and less creative. So the main way chat models are different from LLMs is the use of a schema or a type of message being sent to the model. So we saw a little bit of this before, but essentially the types of messages supported in LangChain are the AI message, which will usually be the response that you get back, the human message, which will usually be the prompt. There's something called a system message, which you can think of it as sort of setting instructions for the model that the model will always keep in mind. So think of things like a persona, or just sort of like a guidelines of how you want the model to act. And chat message takes in some sort of a role parameter. We won't really look into that because even LangChain doesn't really have an example for that anywhere, but most of the time we would just be dealing with human message, AI message, and system message. So how that works is, so from langchain.prompts.chat, you will import all of these templates. So system message prompt template, AI message prompt template, human message prompt template. And then from the schemas, you'll also import the AI message, human message, and system message. So let's take a look at some basic functionality. So if I had a chat model that I called above, I can pass in a human message as part of a list where the content will be the prompt for it. So translate this sentence from English to French. It says, I love programming. Did I run this? And so I would expect that in response, I will get an AI message that will be my prompt translated into French, and that's exactly what I get. So you can also provide in multiple inputs as with large language models. So say I wanted to pass in both a system message and a human message. So the system message will set some sort of a guideline as to how this model is supposed to act. So here I create a list of 2 messages. The first is a system message where I say, you are a helpful assistant that translates from English to French. And then the human message is just, I like programming. So now the model knows what it needs to do from the system message, and the human message is the only thing that will continuously change in the future. And so I can just pass in those messages to the chat model, and then it does the exact same thing. And it says, I love programming in French. Joshua, you have a question?
Yes. Yesterday we were, it's yesterday. We were just sort of stuffing everything into a single prompt, and now this is splitting it out, system message, human message. What's the difference, and why would we want to split it out?
So essentially there's no difference. The model essentially is getting all the same information. So you could put all of this into one prompt and it would work just fine. What this allows you to do is, if you were to make an application where you want the system message to be something that's persistent, you created a chatbot app and you want the model to always act a certain way, but you don't want the user to have to pass in those set of instructions. So I can set that system message as part of my code, saying, this is how you're supposed to act, and you're not supposed to act any differently than this. That's sort of what Bing has done with Bing Chat, is they've passed in that Sydney prompt, which tells it to act how it's acting. So you pass in that system message, and essentially what you're updating every time, what the user is only doing is updating the human message. So those instructions remain persistent. The only thing that changes is the human message.
Okay, got it. And do all these messages count against your context length?
Yes, they do.
Okay. All right. Thank you.
Other questions? Chris.
Do you have to pass in this system message every time, or can you do a one-time setup?
You can do a one-time setup. It again depends on how exactly you set up your code to run. But yeah, depending on how you set it up, you can do it either once, or you need to do it every time. Here, because it's not necessarily being put into any sort of a function, we're gonna have to put it in every time, because every call to the API in this case would be GPT 3.5 Turbo, would be treated individually and separately.
But from a billing standpoint, it wouldn't matter.
No, yeah.
Okay, thanks.
So you can also pass in batches of messages. So this is useful if you want to kind of send it a bunch of tasks. This will probably be done better with some sort of an agent, but you can do it like this as well. So, I can make a nested list here of system messages and human messages. So here I'm saying, the system message for both of them is, you're a helpful assistant that translates from English to French. And the two prompts are I love programming and I love AI. And when I run this, it'll essentially do multiple calls. And the first chat generation is I love programming. And the second chat generation is I love artificial intelligence. So you can kind of batch your messages as well. And as before, you can get the token usage, which is very important, using the .llm output functionality. And you can see that I used 57 tokens using the GPT 3.5 Turbo. And again, completion tokens are what the model sent back. Prompt tokens is what I sent it. And so the total tokens used will be 77. Moving forward, so we'll take a quick look at prompt templates for specifically chat models because it makes sense to introduce them here, but we'll also take a look at prompts in greater detail right after this section. So as we said earlier, so there's the human message, system message, AI message, but there's also prompt templates that go along with this. So say I wanted to create a system message template. So I'm saying you are a helpful assistant that translates from an input language to an output language. I want this functionality to be a little bit more dynamic so I can use a template. And then I use the from template functionality to create the template out of this simple string, because at this point it's just a string. So what I do is system message prompt template is what I use. And then I use the from template functionality and I pass in that string. So now my system message prompt looks like you're a helpful assistant that translates from input language to output language. And then similarly, I'm going to create a template for what the human message will look like. So this will just be simple text because that's what I expect the user to pass in. And then similarly, human message prompt template is what we're using now, again, using the from template functionality, and I pass in that string. And finally, using the chat prompt template, it puts together, it combines the human and system messages, human and system prompts in one single prompt template. So essentially I do chat prompt template from messages because this now is human message prompt template and system message prompt template. So use the from messages functionality and you pass in both of those. So if I run all of these, if I were to add a code block and run this, I should see what that looks like. So the chat prompt template has input variables, which are input language, text, and output language. So text comes from the human, input language and output language comes from the system. I haven't set any sort of parser. It's essentially telling me all the information I want to know about exactly what is going to go to the model. Jesse.
I still don't fully understand the benefits of using these templates versus just using text. I mean, I see that we can put the little curly brackets to parameterize, input language and output language. But that's not terribly difficult to just do with string objects. Like, so
right. It gets
some other functionality that we expect is going to come, or is this just kind of too simple an example? I just don't understand why we need this complexity.
This complexity only gets useful when you're trying to make an application out of it. So if you were to, stick a front end onto all of this back end, you're going to need to parameterize all of this. We want to make these calls to the APIs as modular as possible. So for example, if I made a Streamlit or Gradio application where I want the user to be able to interface with ChatGPT, but use it as a translation bot. So I want the user to be able to define what language to translate from and what language to translate into. And I want them to be able to pass in the sentence that they want to translate. Putting all of that together, essentially I do like in a drop-down list. I want you to translate from English. I want you to translate to French. And this is my prompt. Passing in all of those parameters essentially allows you to pass that information directly to a prompt template rather than having to do some sort of string magic to get it all into like one nice little prompt. And also generally from what I've seen is if you're using a system message template, system message prompt versus putting all of that information, like set of instructions, into the prompt itself. It seems to follow instructions better when it's coming as a separate system message. So it'll read that system message first, it'll calibrate its thinking that way, and then do something with the actual human message. But sometimes I've seen if you were to put all of that system message and the human message in one single prompt, it tends to not exactly follow instructions all the time. So it kind of ensures that, at least from the system message perspective, its behavior is standardized.
Okay.
But yeah, in essence, yes, it's not changing that much. It's only useful when you're trying to stick a front end onto this particularly. Cool, where were we? Okay, so yeah, now that we have that chat prompt template, we've set exactly how this, exactly what is going to go to these models. You can pass in that chat prompt to the chat model, and this is kind of how it'll look. So you pass in chat prompt, you're going to format that prompt. This is where you're going to give it all of its parameters. So input language is English, output language is French, text is I love programming, and then two messages is essentially what is converting this into a message object. So it's taking the prompt, it's converting it into a message object, and it's sending that message object to the chat model. And again, our output is going to look exactly the same because we didn't ask it to do anything different. We just asked it to do it differently. So again, AI message, and your output is the translated sentence. And again, yeah, you can also pass this prompt to a chain, and we'll see more of this in the next few sections. And again, you just do chain.run, and it'll output just the string output of the model instead of giving us the AI message output. This is a little cool. So if you wanted your application or model or just your notebook to look kind of nicer and act a little bit more like ChatGPT, what you can do is do something called streaming. So now it kind of acts like it's writing. It's not really doing anything differently. It's just doing a bit of a time delay as it's getting in information from the API, but it can stream information to your computer as well. And this is nice when you're trying to make some sort of application and you want it to look more like ChatGPT and make it look like it's thinking. Cool. Before we move on to text embedding models, are there any questions? All right. So text embedding models, this will be quick. So essentially embeddings create a vector representation of a piece of text. And this is useful because we can think about text in some sort of vector space and do things like a semantic search when we're looking for a specific piece of text in a large corpus of information. So it's very easy to do this. And most of the time you will commonly only use the embeddings provided by OpenAI. There are a ton of providers for embeddings. All of those are available on the Hugging Face documentation, but we'll specifically only look at OpenAI because that seems to work best for at least all the work that we've done with LangChain so far. So how you get that is just from langchain.embeddings, import OpenAI embeddings. And here you could have imported Hugging Face embeddings as well if you wanted to. And then very simple to call it, OpenAI embeddings. You set that to a variable, and then you can pass in a text saying this is a test document. And there are two methods that you're given. One is embed documents and one is embed query. The largest difference is that they kind of work over different objects. So one works over multiple documents. So embed documents would work over multiple documents, and embed query works over just a single document. So just something to keep in mind depending on how many documents you're working with. So again, simply, need to run that. You would just pass in your text, and then essentially what it's going to do is convert it into your vector representation, and you can take a look at that right here. And this will be just a list of numbers. Questions about any of that?
What does query result do? Sorry.
Sorry, go ahead.
So so embed document is translating the text. So what is embed query translating?
So it's just a difference in how many objects it can work on. So embed documents could work on an entire directory of documents. Embed query will work just on a single document.
Got it. Thanks.
Other questions? All right. So we'll change things up a little bit, and Miranda will now go over prompts and prompt templates.
Hello, everyone. Yes, so now we're going to talk about prompts and prompt templates and get a better idea for exactly how we could use all of these. So hopefully you are seeing my screen right now. All right, cool. Let me get my stuff ready. Okay, so I've went ahead and ran all of the code as Umang was going through it, and he did touch on a couple of the things about prompts that we're going to be talking about, but we're going to try to take a little bit of a deeper dive because I know a lot of you were really curious about how exactly we could format our prompts and also format our outputs. So let's get started. So first of all, the prompt template is how we are constructing our input. And as Umang was saying, this is really useful for some sort of user interface where you only want someone to just input part of the prompt, like maybe just a variable or so, or if you yourself are wanting to programmatically go through a lot of different inputs and just change little parts of it, it's an easy way to do that. So there are 4 main components of prompts in LangChain, or parts of prompts in LangChain. There's the LLM prompt templates. So for basic large language models, not chat models, we can use prompt templates for those. Umang already covered chat prompt templates, so I'll probably just glaze over that one because he did already talk with us about that. The next is example selectors. For us to be able to include examples in our prompt for the model to use. And then the 4th one is output parsers, which a lot of people are asking about. How can we get rid of the new line character that the model outputs? How can we make sure that the output is in this specific format that I want? We will talk about all of that in this section. So just a quick note is that we're kind of getting into the deeper parts of LangChain documentation, which means that the documentation is much sparser. So sometimes none of us may exactly know how something works except for diving into the API reference or diving into the source code. Just because since these are so specific, LangChain typically just has 1 or 2 examples, and that's about it as far as descriptions go. So if you have questions, please ask, but also be patient with me if I'm not 100% sure, because I may just have to go see what's on the website. So on day 1, we worked with a brief example on general LLM prompt templates. So I'm going to go ahead and run this again. If you remember, we have to import the prompt template. And then you can just put in a string as your template. So it says, I want you to act as a naming consultant for new companies. What is a good name for a company that makes? And then in curly brackets, we have our variable called product. We can construct this prompt by passing it the input variable and then passing it our template that we made earlier. And then we can use prompt.format with our assigning variable product equal colorful socks, and it will print that out for us. It gives us the whole prompt that we're sending. So are there any questions about what we did before with prompts, before I get on into how to make it a little more complicated? I'm going to check on the chat. Yep, okay. Looks like we're good. Any questions? Feel free to raise your hand or put it in the chat at any time. So we also talked about setting up our prompt template to be able to take in multiple inputs. So in this case, you would pass in input variables equals this list of adjective content. And this is specifically for a template that instead of assigning to another variable like I did earlier, you can actually just pass it in right here. It doesn't really matter unless you want to change it a lot. So here I have tell me an adjective joke about content, and it will format this for me and print out, tell me a funny joke about chickens, depending on what you pass it. So that's how we could do multiple input variables there. We also have this from template method, where instead of just having to manually say what the input variables are, we can just create a prompt template by already just having these curly brackets in here, and then just telling the prompt template to just know what that is. And because you use these curly brackets, you don't have to specify input variables here. This is kind of a more manual way of doing it. And this is a great way to do it if you just want a fast way to do it and have the prompt template just kind of guess what you want your input variables to be. So when we pass it this string here with curly brackets around adjective and curly brackets around content, when we load the template, prompt template.from template, and then pass it this string, it will automatically know that our input variables are adjective and content. And so here I'm just printing out prompt template.input variables. Let me add a print statement here. And then when we can access the input variables by doing prompt template.input variables, and we can see here that it's taking adjective and content. So it already guessed that for us. So it takes a little bit of the step out of the way. And it comes up with the same prompt. So something else that you may want to do if you have a prompt that you really like or a prompt template that you really like, you may want to save this for easy reuse across some other applications. So LangChain currently supports saving prompts to JSON and also YAML files. I think that's about it, but all you have to do is just say prompt template.save, give it your file name and either .json or .yaml. You don't have to specify any other argument as to what the file is because it will purely guess just based off of the extension at the end of your file. And it will save that. So if I want to save our prompt template, I'm just going to press this. And now if we go over, because we're in Colab, if we click on our file system, we can see, oh, there it is. Awesome prompt.json. And it goes ahead and saves that for us. So if you're in Colab, it'll save this in your Colab session, and then that will get deleted at the end of your session when you click the red X. But if you're on your personal computer, it will save that to your computer permanently. So if you wanted this, if you're using Colab and you wanted to save it forever, you could click this download button here. So pretty useful if you want to have some prompts that you use consistently and that you can use across applications. And here, just to show you how to load a prompt that you saved, you can have langchain.prompts import load prompt, and then all you do is just call the function load prompt and give it your file name. So I'm going to load this prompt and then print it. And so in this case, it tells me that the prompt has the input variables adjective, content. There's no output parser. We'll talk about what that is. And then tell me adjective joke about content, which is exactly what we gave it before. Now I'm going to format this loaded prompt just like I did before, except pass it the adjective hilarious and content AI. And there we go. Tell me a hilarious joke about AI. So do we have any questions? I know I kind of breezed through that, but are there questions about using these prompt templates for LLMs? All right, so it is pretty straightforward, and we'll get to the more interesting stuff after this section as well. So the chat models, as Umang said, takes in either a human message, an AI message, or a system message. Humans coming from what the person is typing into the model, AI message being the response from the AI model, and the system message is what you set in your prompt template. And as someone pointed out, this prevents a user from being able to change a very polite model to a very nasty or rude model, which is really good because we don't want our models to be mean to people or let people change it to be mean. So the I'm not going to go all into this because Umang already talked about it, but I will breeze a bit through it. So we have, we can do the same thing with chat prompt templates, giving human message prompt templates, and then putting the system message and human message into these right here. So that's just a basic overview, but I didn't want to bore you with information you already got. Okay, so now we're going to get on to example selectors, which is a bit more interesting in my opinion. So sometimes you want your model to have a specific kind of output, but maybe the only way is to describe that output or to give it an example of what you want. And we can actually do this in LangChain with their few-shot prompt template and their example selector. So first step in this is that you actually need to have example questions and answers. So here we are importing the few-shot prompt template and the normal prompt template. And you can create your own list or dictionary of examples. So in this case, it's a list of different dictionaries we have question, who lived longer, Muhammad Ali or Alan Turing, and then kind of how you want the answer to be. So you want the model to then ask itself, are follow-up questions needed here? Yes, follow-up. How old was Muhammad Ali when he died? Intermediate answer. So you're kind of giving it this process to follow. And if the model gets enough of these examples, it will see that when you ask it a question, it wants it to follow kind of this process here, which is really neat. And then it'll give you the final answer. So I'm going to run this just to go ahead and have our examples. Does anyone have questions about examples so far? We're going to show how to use them, but does anyone have questions about how to set up these examples?
Yeah, how did you come up with these answers?
This is off of their documentation. So I didn't do this as far as like, how did I come up with these answers? I didn't. This is just off of LangChain's documentation.
Got it, thanks.
Yeah. Yes, Jesse.
These examples also count. How do they count in terms of tokens? They count in terms of you're sending them as a part of your prompt. Is that how this is going to work? Okay.
Yes, exactly. And so we'll actually talk about how we can tell our model to choose the examples so that we're not sending all of them to it. But right now, as we have it set up, we're going to send all of the examples. And then after that, we'll show how to let it just choose a few examples to look at. But yeah, that's a great point.
Yeah.
Right. So now that we have our examples, we need to format them in a way that our model can read. So you just use the prompt template for that. You pass it your input variables. In this case, it's question and answer, just because that's what we set up here with our examples. And then template equals question. And then we have our question and answer. So this is just kind of what the chat or what the model is going to read in. It's going to read in our question, and then it's going to read in how it should answer. So now we can print how it would format this and just select the first example. And this is what the model would receive if you went ahead and sent this example in. So what's the difference between this and a prompt? In this case, we're not actually giving this to the model as a prompt. We're giving it to the model as an example, and then we're going to give it a prompt to say, now answer this question in the style of this example. And then that's all going to go to the model, as Jesse pointed out. So that will count against your tokens. So LangChain, to accept these examples, it has something called a few-shot prompt template. And just to break out that name, few-shot is a term that we use when we give models just a couple examples and then expect them to replicate that. So you don't have to go through and train the model a ton. You just give it a couple of examples. It's kind of like if you showed someone like 3 pictures of a cat and then expected them to be able to identify a cat every time they saw a picture of one. It can work pretty well, but you want to make sure that you get really good examples. So in this case, we're going to send this few-shot prompt template, our example list, as well as the example prompt that we created up here so it knows how to format it. This suffix part is just exactly what we kind of had up here. They don't have a lot of explanation for this suffix part, to be honest. So I need to look into the API reference to really see what that's doing there. But then the input variables, all we're giving it is the input. So this is kind of just like wrapping our entire prompt template into an example prompt template so that when we send our input, it compares our input to the examples that we've sent it. So it's kind of like thinking in layers. And if that's confusing, please do ask me questions because I know it's a little strange to think about. But in this case, we create our mega prompt from few-shot prompt template using our examples. And now we can format a new prompt. So this is not something that was in our examples. It's a new prompt that says, who was the father of Mary Ball Washington? And we want it to kind of think about this in terms of our examples before. Oops, I didn't run this previous cell. And now I can run it. So in this case, we're just formatting it. And so now we have this other question. So it's kind of like giving it a fill in the blank. So we get all of these examples up here. who lived longer, Muhammad Ali or Alan Turing? And then it goes through the steps to answer the question. When was the founder of Craigslist born? Who was the maternal grandfather of George Washington? And so you can kind of see that all of these questions are usually multi-step questions. So you need to get some information before you can answer it. So kind of like this, are follow-up questions needed here? Yes. Who was the mother of George Washington? Because you need to know who his mother was before you can know who his mother's dad was. So kind of giving it multi-steps. And then finally, we have our new question, and we're hoping that it will answer it in the style of these other ones. And then in this case, you would just send this prompt direct to your model. So what if we don't want to send all of the examples, as we stated before? That's a lot of tokens that it's taking up over here. And instead, we just want to use the ones that are most relevant to our current input. So maybe you have a ton of examples, and maybe they're very diverse. You want your model to be robust and be able to answer a myriad of different questions, but then you don't need it to take into account, questions about, maybe some of these multi-step questions. You don't need it to take that into account if it's just a really simple question or something, or if it's providing you a list. So instead, we can give it an example selector. And LangChain has a couple different example selectors. The one that I like the best is this semantic similarity example selector, because that chooses the examples to send based on how similar the current input is to the other examples. And then it'll select the examples that are the most semantically, so in meaning, they're the most similar. And you can do this a couple different ways. They do it with cosine similarity. And so to accomplish it does need a vector store, which you get with Chroma. So in this case, we're importing the semantic similarity example selector, it's hard to say, Chroma, and then OpenAI embedding so that it can embed the examples, embed your input, compare those, and choose the example that it wants to send off to your model. So we start up the example selector with semantic similarity example selector from examples. You give it your examples to select from. You give it the embeddings that you want it to use. So just like Umang talked before about models that just do embeddings, that's something like this, where it's just going to apply OpenAI's embeddings to our examples. Give it the vector store that it's going to be able to store these examples in so that it can do the comparison. And then you can give it k=1 is the number of examples to produce. So if you want it to use one example, this would be 1. If you wanted to use 3 examples, you set it to 3. And then it's going to select the most similar to the input. So if we run this with our new question, then this is just a fancy print statement. And then it's going to print out the example that it's going to use to send to the model. So who is the father of Mary Ball Washington is the most similar to who is the maternal grandfather of George Washington. And I'm assuming these are the most similar because it's talking about people's parents or grandparents. And I don't know if it took Washington and was like, oh, this is similar. I would have to look into the embeddings. So we have this now. Are there any questions before we send it to the few shot prompt template? I know we're kind of breezing through it. Yes, Chris.
So when you call OpenAI embeddings there, is it sending something to the OpenAI API, or is everything happening locally?
It is sending something to the OpenAI API. You are it's kind of like before you get you're not getting any kind of token generation back, but it is embedding the tokens for you into a vector space. So you do need your API key, and it is calling the API.
Got it. But is it sending all the examples and getting an example back? Or I guess I'm not quite understanding what's happening.
I'm not 100% sure, how that factors into billing, if that's what you're getting at. Umang or Sharo, do you guys know?
Well, I was going to say that it doesn't have to be.
Oh, Jesse,
this may be a very different model, which is, you could send it to any model which produces embeddings, which is very likely not going to be a chat model. It's going to be instead, just a regular run-of-the-mill large language model. And you probably have, because it's you probably have your choice of where you want to send it. a cheap model that gives you just sort of quick, cheap embeddings versus others. You might be able to use a local model. You might be able to. And even if that's not something which is available now, this is open source. You could roll your own.
Thank you.
Yes, thank you.
Jesse, you have a question.
Yeah, for these, for the example selectors and the few shot, what is, I guess, what is the better use case, or maybe it's both? Is this helping you to better format how you want the answer to come out, like with this question, answer, follow-up, intermediate answer? Or is it more about learning the right content to get the answer more accurate?
So it's more of the second one. So it's kind of like when you ask ChatGPT a question and it doesn't exactly understand what you're asking it, and it kind of gives you an answer that's not relevant. And in that case, you want to be able to say, oh no, when I'm asking this, I want you to give me an answer like this. So I imagine you could do something that's maybe along the lines of writing Python code, where when you say, I want you to write Python code to do this, and then you give it an example of code that you may want it to write. That could be an example of something. So it's not exactly making the output in a specific structure. That's kind of more into output parsers, which we're going to talk about next, but more in the lines of guiding its answer towards what you want.
So think about one other thing to think about here is this is in the neighborhood of chain of thought. And one thing that's different about these models is as you do more, you produce more tokens if they are aligned with what you're trying to solve, you're getting more compute. So you're forcing the model to think about it more rather than just shooting out an answer. You're forcing it to actually do a chain of thought. So it's doing more computation, more useful computation to get an answer. And this is forcing it to do that. You can't jump, you have to take it to each step, and therefore you're getting better and more compute. And so you're more likely to get the correct answer.
Okay, so is this a pattern that would be useful? I guess this is actually my real question. Is this a pattern that would be useful to build sort of like an automated grader where I could give it a rubric in these examples and say, here's an example of a high quality prompt. This is a medium quality prompt. This is a low quality prompt. Now assess this input document based on these examples that I've given you, along with explanations as to why?
Yes.
Yeah, okay. I think so too.
Yeah, that's a really great application. Michael.
Yeah, I just curious because when you do this, you actually put a vector database called Chroma. Does that, I mean, I guess I have two questions. Does that mean you can replace that with, for example, Pinecone or some other ones? Or secondly, it's kind of a little strange that when you connect to Chroma, you don't give your key or user ID or something like that.
Yeah, so that's just how Chroma works. So up here I have from langchain.vector stores import Chroma because that's the vector database I want to use. If you wanted Pinecone, you could put in Pinecone, but then you'd need your API key or your user, some sort of authentication. Chroma runs locally, so it actually installs the vector database on your own machine and does those calculations there. And so that's a good option if you don't want to send it to some other database and you just want to do it all on your machine. It's also really nice for these examples specifically, because then I don't have to ask people to sign up for a Pinecone API or a Deep Lake API or something.
Got it.
So that was purely for instructional purposes that I chose this one. But yes, you can, depending on the ones you import, you can just pass whatever vector store you want into this argument here.
Mm. Got it. Thank you.
Yeah, great questions, everyone. Okay, so we have created our examples, kind of talked about why we would want to use them, and then we can give so we created example. It's kind of multi-steps. We created our examples, And then we gave it an example selector so it knows how to choose the examples. Now we're going to give those to our few shot prompt template so that it can select the example, get the prompt, and then compare those. So here we go. We've got our prompt, few shot prompt template. We're sending it our example selector so that it knows which example to look at. We're sending it our example prompt, which is the prompt that we formatted. We're sending it, you know, just kind of how it should expect the input to come in. So question and then input. And then the input variables in this case is just input. And so our new, and that is what we're sending it new. So our new input is who is the father of Mary Ball Washington, and it should give us the example that is the most similar, which is this one. And so what's the difference between these two? This is just the example selector that shows you the example it's going to choose. This is actually what you can send to your model. So once you get this prompt, you can give that to your model, and then it'll know exactly what example to look at, and it'll know how to answer your question. There's a lot of other different example selectors. You can check them out at this link. They do slightly different methods. They're all a little bit different. I think the one that's most useful for our cases that we're talking about right now would probably be a semantic similarity, but you can choose it based on a whole other range of factors. You can even create your own custom one if you so desire and want to put in that work. So are there any questions about examples before we move on to output parsing? Yes, Chris.
How do you actually run or predict with the few shot prompt template?
Yeah, so it's just like passing in a prompt. So you would call your LLM and then your prompt. So let's see if I already have it depends if my runtime already has the LLM connected, but if I just add some code here, do LLM prompt, oops. Oh, it depends on how we set it up. I need to look. This is kind of where their documentation for prompts ended, but that is a good question to look up, you know, sending it to the model.
Thank you.
Mm-hmm. So I will actually show you, if you want I'll open this link for y'all. So this is the example selector, all the different ones that they have. We just looked at similarity example selector. So I'm going to click on that one. And then this is kind of the example that we just went to. And it kind of just stopped here. So is there a specific way to send this prompt to the model? Maybe. I will need to look just for full transparency.
And one thing to sort of keep in mind, this is a really elegant way to extend the capabilities of your models without having to do custom training. This is in a real way sort of is replacing or mitigating the need for instruction fine-tuning. Because remember, with these large models, you can't do additional training on them. There's going to be like no additional training on GPT-4. So with the largest models, this is going to be the only way for you to get new capabilities of solving new types of problems. But this is a really nice way where you can have a whole host of different types of approaches all stored in a vector store, and you choose how you want to solve a problem based on its similarity. I love this.
That's a lot of fun to mess around with. All right, so moving on to output parsers. So this is when we want more structured information instead of just the text that our model may send us. So in this case, we can use the classes in LangChain called output parsers that are going to structure those responses for us. So in regards to output parsers, there's two main methods that you must implement. The first is get format instructions, which returns a string containing instructions for how the output should be formatted that gets sent to the model. The other one is parse, which takes in the response from the language model and then parses it into the structure that you gave it in those instructions. There's also an optional method called parse with prompt and then a string that takes in a response from the model and the prompt that generated that response, just in case your output parser, however you set it up, if it needs to, for some reason, know the prompt that generated the response to properly structure it. That's kind of a more rare use case, but it is useful to know if you run across something where you need to pass in both. So as always, I have the link to the documentation here. You can read all about the different kinds of output parsers. The main one that LangChain likes to put in their documentation is called Pydantic. I have an example of that one below, but it is way more complicated. And just for today, I wanted to show you a simpler one and then kind of get into the more complicated examples. So a simpler parser that they have is structured output parser. This one is literally just give it the structure that you want using schemas. So first you define, so we're going to import all of these and then define your response schema. So this is just the structure you want it to have. And you add these, response schema is going to be a list of these response schema objects. So they take in a name and then a description. And this is kind of like in the tools selection that we showed yesterday, where it's going to understand how the schema works based on the description that you give it. So depending on how good this description is how useful it will be to your model, which is actually pretty cool. Instead of having to write code that structures something in a specific way, you just say, this is the answer, description, answer to user's question. This is the source, description, source used to answer the user's question, should be a website. That's really great, instead of having to write all of this code to check that it's a website, check that it's, you know, a source to the question. So instead you can just pass it these plain language instructions, which is super cool. So now we can run this response schemas, and then our output parser, we're going to start up as a structured output parser from our response schemas that we did, and then just pass it that response schema. So now we have our output parser, and we can use it to get the instructions from the schema and then put that into our prompt template. So the format instructions, this is that one, the first method that I showed you. First, it has to get the instructions from this schema. So this is just kind of a list of what to do. Format instructions is going to put it into actual set of instructions that the model can read. And then once you get these instructions, you can add this as an extra variable that they call partial variables. So instead of an input, which is the question you're going to ask, this partial variable is going to take in a dictionary of format instructions, and then you can pass it through that. So if I run this, now our prompt is going to include these instructions on how to format its response. And here's the cool part, is we start up our model, we give it this input here. So question equals, what's the capital of France? And then we want our output, and we want the output to be what the model is sending, and we can just send input. We run that. So I'm going to wait a little bit for this output, but the second method that you want is this parse, because you can just get, if I wanted, let's see, we could just see what this output looks like. This is without parsing. And so it'll kind of be, you know, this JSON thing of how it tried to structure the answer. And then you do .parse to parse it into something that we can read more easily. And so now we have answer Paris, and source, it gives this website right here. So are there questions about this process?
So what is the underscore input? Can you show that?
Yes, I don't know why they specifically did this underscore. I kept it because it was in their documentation. I thought maybe they did that for a reason. But yeah, they just put an underscore before this variable. I don't really know why, but the input is just putting your question into the prompt.
Okay, can you show what that looks like if you were to print the underscore input?
Oh, yeah. So if you run that, it's just the text.
I see.
Oh, and so here's the what's the capital of France. Here's something that I didn't notice before, which is fun to notice things live. But it says this must be how they start up the prompt, which is interesting. So it looks like it's instantiated with answer the user's question as best as possible. The output should be markdown code snippet formatted in the following schema, including leading and trailing things for JSON, which is interesting that's how that works. Yes, Holly.
Yeah, so you're just telling it to run to the internet to grab the best answer. Is that right?
Yes. Yes.
Okay,
In this case.
So the question, go ahead.
I wouldn't say we're sending it to the internet because this is GPT 3.5 Turbo on its own. It doesn't have access to the internet, and we're not giving it access to the internet using any sort of Google search API. I don't even know if that's a real website. It might be, but it could very possibly be something that it just made up. Okay,
Yeah,
it does seem like a real source, but
I think it might just be something it already had.
Yeah,
right.
And they've started to enable some. So they've started to enable some web searches from ChatGPT 3.5, sort of under the covers, shifting and growing capabilities.
Yeah, it's kind of something you'll have to play around with and see what it does. Specifically, it's giving this because we asked it for a source and we said to get to that it should be a website. So I don't know if we did some other kind of source, maybe it'd be different.
Yeah, it just seems like there's tons of potential of algorithmic sort of malfeasance as privileging certain websites over another. Okay.
That's why I like that this is open source and you can actually, in plain language, be much more directive about where it gets, especially if you're using plugins as well. So, but you're absolutely right. It's great that it's language driven though, so you can kind of see, okay, how exactly is it doing this? So,
thanks.
Yeah, and it's one of those things that you could really just dig in and find out how it's doing the things, and then how different prompts affect what it's doing. And you could spend a long time just investigating. So here's an example of using this in a chat model. So just like we discussed, the chat models are a little different, where they're expecting a human message and then the AI message as a response. So we can format this using the chat prompt template, with the message being this, with our format instructions and the question. We have our input variables that the user will give, which is the question, partial variables, which includes the format instructions, and then we can pass it those format instructions. So if I run this, we now have our prompt for the chat model. And then here we have the underscore input, don't know why they did that still, formatting the prompt, and then output is sending it to our chat model. Now we can parse that output to be exactly how we want the output to appear. Yes. Holly, do you still have your hand up? Oh, okay. Chris?
Yeah, here, wouldn't you want to change that human message prompt template to a system message prompt template and then wrap the input question in a human message prompt template?
Probably. This is just what was on their documentation. Why they did it this way, I'm not really sure. This is kind of just all they have for this example. So I haven't really dug in to see like what works better. Mong, do you have something?
Just because I'm seeing that it says answer the user's question as best as possible, and then in that same thing, it's passing in the instructions and the question, it makes me think that the way that this is being done, it will be better to pass it in as a human message so it can actually consider it as a prompt. If this was just a system message, it wouldn't actually do anything. But you could, I think the better way to do this probably would be to split it up into a system message and a human message, where the system message would be the format instructions and the question, and then the human message would be, or I guess the system message would be answer the user's question best as possible with the instructions, and the human message would be the question itself. But given that they're doing it all in one place, it's best to put it in just one human message. So essentially, it's just one prompt.
Makes sense.
I think it's also probably useful to think of it as like they are putting these tutorials and instructions together as quickly as possible. It may be that like this is just something they kind of did really, really fast and it'll get better over time. I mean, that's like Occam's razor, right? Like throwing some stuff up here to get ideas and it'll probably get better through time.
Yeah, that's kind of also what makes this documentation hard, is it's difficult to tell what is in the documentation because it's actually the best practice, or what is in the documentation because it's what they could get up there. And then some of the documentation is even made automatically from the source code using like a special library. So some of it's not even written by people and it may just be bad anyway. So one of those things that's evolving and you guys all get to be part of it. So another useful output parser, I'm not going to get too much into it because I see we're kind of running out of time, but you have a comma separated list output parser that literally just takes in, if you ask it for a number of things and then it puts out a number of things, it will give that to you in a list you can see here. So we asked it for ice cream flavors and then it gave us vanilla, chocolate, strawberry, and it very nicely already put this into a list for us to use. So you can see if you're maybe generating data or something, you can output that in a list and then use whatever data processing library you want to use. The most interesting one is Pydantic output parser. This uses Pydantic library, which allows you to validate data and manage settings in Python. It is very advanced, so I would only recommend really going into this if you already have one that you can copy and paste, or if you know a lot about creating classes yourself. So this involves creating a class that defines how your data structure should come out. And the documentation for that is on the LangChain website. But you can see it kind of gives this joke class where you have a setup, why did the chicken cross the road, and then a punchline to get to the other side. So kind of a way to have more dynamic output parsing. But that is all that I wanted to go through on prompt templates and outputs. So are there any questions before we move on and perhaps take a break and then finish out this notebook? Yes, Paris.
Hi, I had a question regarding the, I guess, is there a way to use this so that, I'm just trying to think of the way where we would not get like made up citations. Is there a way you could actually give examples or like give it an output? Like give it an example of an output so that it would not make it up and it would actually be actual citations instead of like the model making it up.
Yeah, so I think that would be combining the examples, the example selectors, and the output parsers, which I have not played around with, but I like that idea a lot. So maybe you have question, answer, and source added here, and then list your source, and then maybe you say something that in the system message that says only return sources that are from this type of website or something like that. But yeah, I can definitely see you being able to do that.
Yeah, and of course, if you want to be 100% sure, you would use some sort of an agent or some sort of a tool like a Google search tool that will definitely give the chatbot access to the internet. I just saw, I think Isaac said that he tried running that exact same code again, and for the Paris website, it just came up with something that didn't exist. So
interesting.
It got lucky in our example, but to definitely ensure that it does have access to the internet, you'd use a tool.
Yeah.
And so the agent is especially interesting one, because then you can see, you can think of an agent that the sole job of which is to validate the information is there. If there's a website, does it return a 404? If it is saying that it got information from a particular document, doing extractive question answering and see if you meet a threshold of the answer you get through extractive question answering, matching close enough with what you got with the generative AI. So and this is all layers on top, right? And none of it is like 100%, but you can mitigate. And that's something to keep in mind. It is generative AI. So this is not software, which is validated and then will work that way forevermore. It's, you've got to build assurances around it.
Yep. All right. Well, that's all I have on prompts. So I'm going to pass it back to Umang. Do we want to take a break, Umang?
Yeah, sure. We can definitely take a break. Let's take 5 minutes and be back at 10:30 a.m. And we'll see you then.
Hey, Jesse, since we have a second, would it be possible to discuss validation in one of these kind of sessions more in terms of using an agent? Because obviously this is great, but even in one of the examples I was talking about earlier of, as a professor, if you're giving examples of this is what I would expect for a good response, a medium, and you'd want to make sure whatever you're getting back is correct. Because if I'm still going to have to go through every single paper that I had and make sure that what I got back from the large language model was valid. So something that really kind of focuses on making sure that what you are getting back from the large language model is what you're expecting.
Yeah. Umang was actually part of a workshop that addresses, but don't know if it got to the core. We certainly can have the conversation. And Holly, I think this would be a great workshop for us to have in the fall, because, looking at the responses that you get, looking at bias, looking at, right? I mean, because that's all of a piece. And because this is not just, run a test, this has got to be, mitigation. It really is a much deeper conversation than just, we'll run this agent. Yeah.
Yeah, and especially.
And I think that the answer to this is not in CS, right? This is not a computer science answer. This really is much more of a humanities answer of what do you mean when you say that the answer is more correct. So, and just like when we were looking before at the similarity of in choosing the training examples that we have, from me as a cognitive psychologist, I was looking at that. That's a computer science answer of what is the cosine similarity closest, and then you choose that one as your training examples. But as a cognitive psychologist, I'm realizing that it's picking up the surface features to make its analogy, when really there's deep structure that you ought to be using as well, but that's a whole different thing. So it's kind of like computer science and AI researchers have taken us to a certain point, but they can't go a lot further on their own. So now we have to take it further. So yeah, Brian, I'd say definitely we can. I don't know if we'll have time in the sessions. We can talk about it a little bit, but we can definitely talk about it in office hours and dedicate some time there.
Awesome. Thank you.
Mm-hmm.
Yeah, Jesse, this question of deep structure and embedded meaning and semantic webs. Yeah, I think there is going to be a point for the little that I, I'm not a computer scientist, that I think there will be a point where some of that stuff we can get deeper tokenization.
Yeah.
But as we get deeper tokenization, and so, one of the things that I just wonder is if we don't do, like you're saying at the front end, is, what are we getting back? And doing a really deep dive into the complexities of what we're getting back. That's why I was asking that question about Paris. Yeah, we all can agree that Paris is the capital of France, but there's a whole bunch of other stuff about that choice of what website that is. Does it exist? Right. Does it exist? Is it authoritative? Yeah, it's I don't know how. I mean, we're gonna have to get on top of this pretty quickly, don't you think?
Before absolutely.
Before the questions are already answered in ways we might not like.
Yes, absolutely. And that's one of the purposes of the Data Science for Social Good program, and I promise I'll stop talking about because I realize that our time is up, is to at least begin down that road. So before people start adopting and just believing that we create some of the structures to raise the questions, maybe mitigate, but boy, we have a lot to do, like the university.
All right, welcome back. So jumping right back in, thing that we're going to talk about is memory. Can everybody see my screen? All right, so far, everything that we've done, we've seen that by default, these large language models and chat models are independent, they're stateless, and they don't quite remember what's been done before. So every single query sent out is independent of another one. In some applications, especially some sort of chatbots, it is necessary to remember these previous interactions, both in a short term and long term. So the most basic memory module in LangChain is the chat message history class. We don't use this very frequently, but it can be useful for saving messages sort of outside of a chain. And this is also a good way to kind of get an idea of exactly what these memory objects look like. So to start, it'll be from langchain.memory, import chat message history, and how you initiate a chat message history object is just by calling it. And then you can just do history.add user message. So this would be like that human message, and I can say hi. And then you can add an AI message and say, what's up? So now you can look at all the messages in the history, and you can see that it's a list of messages that have been sent, where the first message was the human message saying hi. The AI message was what's up. So this is just kind of dummy coding history into this object, but this is pretty much exactly what every memory object looks like in LangChain, with minor modifications here and there. But the simplest type of memory that you will actually be using at any point using LangChain is the conversation buffer memory. So it's just a wrapper that's around the chat message history, and it extracts the message into a variable. So you import conversation buffer memory from langchain.memory, and it works exactly the same way. Memory, you add the user message, you add the AI message, hi, what's up? And then you can see you do memory.load memory variables instead of history.messages. But you still see that, for the history, the human said hi, AI said, what's up? You can also get the history as a list of messages like we did above by passing in the return messages equal true parameter. So exact same thing as before, but with this slight modification. And now this looks a little bit more similar to what we saw right up here, where the history is a list of messages where the first one is the human message, the second one is the AI message. This is just useful to know how it's structured, just in case you wanted to be able to parse through a specific part of the memory object and get at a specific instance of a query that was passed. So just talking a little bit about the structure of these history objects. So where it's really useful is actually using it in a chain with a language model. So how we're going to do that. So from, we're going to use a simple LLM. So from langchain.llms, import OpenAI, and then I'm going to import the conversation chain, and we'll take a look at chains a little bit more likely on Friday. This conversation chain essentially is a chain that works well to incorporate memory and have a more chatbot-like interaction. The LLM chain does not work with memory. So if you wanted to use memory in your LangChain, you would likely not use LLM chain. You would use, at the minimum, a conversation chain. And there are more chains that take this functionality even further, but this is the basic one. So I set my LLM, so OpenAI temperature equals 0, so that my model is acting more precise and less creative. And then the conversation or the chain, you could call this whatever you want. So I'm calling the conversation chain, I pass in my LLM, I'm passing in my memory, which is the conversation buffer memory. And then I'm also passing in this flag called verbose equals true. So verbose equals true essentially allows you to see a little bit more in depth into how the LLM is actually working and thinking. So I forgot to run all of these. I'm going to run those real quick. All right. So this is what it looks like when you have the verbose equals true flag set. So you kind of see a little bit more into what exactly the chat model or the large language model is doing. So it's thinking a little bit. So, entering a new conversation chain, the prompt after formatting is the following is a friendly conversation between a human and AI, blah, blah, blah. This kind of comes with the conversation chain as default. And then it starts printing out the current conversation where the human says, hi there. And the AI prints out, hi there, it's nice to meet you. How can I help you today? So that kind of gives you an idea of exactly what these models look like. And then here, I'm going to pass in a second message. I'm saying I'm doing well, just having a conversation with an AI. So you can see now it has some history going on. It remembers that I first asked hi, then it knows that this is what its response was. And now it sees that this is the next human query, and then it responds with, that's great, nice to have a conversation with someone new. What would you like to talk about? And this keeps going on and on. I can say, tell me about yourself. And then again, it has all of that history here, and then it gives a response. So questions about that? That kind of covers the basics of what memory looks like and how you can have a little bit more insight into how exactly the model is working. Chris.
Oh, sorry.
Oh, sorry, Michael, go ahead. Yeah.
I think Chris raised hand first. Go ahead.
Right. Yeah.
Okay. And is it possible to have memory per user? Like if I have this on the back end and I have 1,000 people using this.
Yeah. So it'll depend on how you've set up the application. If the application itself is capable of running in parallel as separate sessions, yeah, totally. You can set that up, but that boils down to exactly how the back end and front end is set up. In terms of the back end, this is kind of it. The front end will allow you to actually run it as separate individual sessions.
Thank you.
Michael.
I guess what's the difference here, the chat model, the chain, and versus the conversation chain?
So the chain that we saw earlier was the LLM chain. The only difference is that this chain allows for the use of history. The LLM chain does not. So the LLM chain is very basic. All it allows for you to do is pass in some sort of a prompt. It could be a regular text prompt or a prompt template and an LLM. What this allows you to do in addition to that is also pass in this memory. And it also allows you to do the verbose equals true, where you can actually see exactly what the chain looks like. But in essence, not much more difference apart from the ability to incorporate memory.
I see. I was kind of more like the chat model part of the LLM chain, I guess. Okay, that makes sense. Thank you.
Other questions? Chris.
And does the chat model by itself, if you're using the raw chat model, does it support memory out of the box, or there's just no way for it to have memory?
Yes, it does. You just need to incorporate it in using a chain. Like the chat model, if I were to call, this instead of this was chat OpenAI instead, it doesn't on its own have memory, but I can give it memory using this chain.
Thank you.
Cool. So that's like the most basic form of memory, right? So you're keeping a record of every single conversation that has taken place in this session with this large language model. But sometimes that can be problematic because all of this is still taking up context, because essentially every time in order for the memory to really work is essentially what this chain is doing is passing all of these conversations in as full text to the model as part of the prompt. So that's fine, but that becomes problematic the moment you start running out of context length, right? At some point, this will start telling you I've run out of context and I can't work anymore. Or it will start forgetting and it'll start losing messages on the back end. So you might want your memory to act differently depending on your own use case. So there are different types of memory for those specific use cases. But before we get into another example of another memory type, just simple way to export your message history. Say you've had a long conversation with an LLM and you want to save those results to, say, a JSON file or a dictionary. Very easy to do. We imported chat message history, so this is our history where it's the old one, just the hi and what's up. All I need to do is use this messages to dict function. And essentially what I'll do is I'll take my history and convert it into a dictionary. And then I can very easily take that dictionary and, save it to a JSON file. Similarly, you can also load messages. You can load a history from the dictionary we created above. So I can use the messages from dictionary function instead and pass in that dictionary. And then now it reads it in as a memory object instead of a dictionary. So nice ways to keep track of any conversations that you're having, save results. So this would be a good way to kind of do that. But circling back to different memory types. So as I said, there's different, you likely want different memories for different use cases. We just took a look at the most basic one, which is conversation buffer memory. But there's also something called conversation buffer window memory. So essentially what this does, it keeps a list of the interactions of the conversation over time and only uses the last like K interactions in the prompt that it's sending out itself. So, say my conversation that I'm having with the LLM it needs to have some idea of what's going on, but it doesn't need to know what happened, say, 5 questions ago or 5 interactions ago. I can just tell it to keep the last 2. And so I can set that here. So conversation buffer window memory will allow me to keep the sliding window of interactions so that the buffer doesn't get too large and I don't run out of context length. So similar to what we did before, very simple. I'm creating a conversation chain, passing in my model. I'm setting a K equals 2 so that it'll only keep the last 2 interactions in the memory. And the memory I'm setting here is the conversation window buffer memory with the parameter of K set to 2. Also going to say verbose equals true because I want to see exactly what's going on. And then we can run this. So I'm going to start right there. Conversation with summary.predict. I'm giving it an input. Hi, what's up? Right. And the AI responds by saying, hi there, I'm doing great, helping a customer with a technical issue. And then I ask it again, what are their issues? And it responds, it's having trouble with their Wi-Fi network, helping them to troubleshoot it. And still, it knows everything that we've talked about so far. And then I keep going on ahead. Is it going well? It still has everything because that's the last 2 interactions. And this is where the first interaction will not appear anymore because it's past that buffer window. So that first, hi, what's up? Hi there, I'm doing great, is no longer part of my buffer. It just starts at what's their issues. And continues the conversation on from there. So it's a good way to kind of control how much memory you're using up and how much context length you're using up if your conversation is one that doesn't require all that detail. Questions about that? Cool. Moving forward. There is another memory type that I wanted to mention. There are a lot of other memory types as well. So there's a memory type that will essentially take in your entire conversation that you've had so far and summarize it. So that's another way of shortening the context length that is being used by the memory itself. You'll lose some granularity, but you won't lose it entirely like you are here. So it'll still have some memory of what the conversation has been so far. It just summarizes it. There are vector store back memories, just in case you were saving your responses to some vector store, your memory can work off of that vector store as well. One specific memory type that I found really cool that I wanted to talk about was entity memory. So this entity memory allows the model to remember things about specific entities or people or things that you're having a conversation about. And it extracts information on these entities using LLMs and builds knowledge about that entity over time, also using LLMs. So it's using an LLM in the memory itself over time. So that's the conversation entity memory, and works fairly similarly, except that this needs a prompt. So again, I'm using the conversation chain. I'm going to pass in my large language model, verbose equals true, but I need to pass in this prompt, which is the entity memory conversation template. I don't need to set it to anything. It just knows what to do with it. And then my memory is conversation entity memory, where since it needs a large language model to kind of develop this understanding of who this object or entity is, it needs a large language model. So I'm going to give it the exact same large language model that the entire chain is using in general. And this is how we can see exactly what's going on here. So conversation.predict, Devin and Sam are working on a hackathon project. So, this is the prompt that comes along with the entity memory conversation template. There's a whole set of instructions that it gives, and you can kind of read what exactly that is, but it essentially is saying that you're trying to keep track of entities. And so it takes your input and it breaks it up. So it knows that in the context, there are two entities already. Using the LLM, it knows that there's Devin and that there's Sam. And the current conversation is Devin and Sam are working on a hackathon project. And then it responds with, sounds like a great project. What kind of project are they working on? So what this has done right now is it's already decided that there are two entities that you're talking about. And you can look at what those entities are by looking at conversation.memory and then look at the entity stores store. So you can see Devin is working on a hackathon project with Sam. Sam is working on a hackathon project with Devin. So it knows these two entities and it knows information about them. And then we can take this further. I can say they're trying to add more complex structures to LangChain and so on and so forth. In the context, it already knows this, that, they're both working, these two entities are working on a hackathon project, but it's now identified that LangChain is also an entity that it should probably keep track of. And so now it is going to start tracking information about LangChain as well. And then I can say they're adding in a key value store for entities mentioned so far in the conversation. And so now it knows, in addition to Devin, Sam, and LangChain, there's a key value store that it also needs to keep a track of. So it's smart about that. It knows exactly what to keep track of, what entities have been mentioned in the conversation so far. And this will keep going on and on and on. And then you can just ask a question, what do you know about Devin and Sam? And then it uses that context to respond. So it knows that Devin and Sam are working on a hackathon project. We knew that. It attempting to add more complex memory structures to LangChain, including a key value store for entities mentioned in the conversation so far. So really cool. And then you can again go look at the entity store and see, it has information on Devin, it has information on Sam, it has information on LangChain, and it has information on the key value store. So really, really cool for specific use cases. But I don't know, I thought this was a very interesting approach to using memory, and yeah, one of the cooler memory types that they have in LangChain. Questions about that? Cool. In an effort to save some time. Oh, okay, we're at 10:50. Okay. I don't know if I want to start indexes because that's a lot. So I'll kind of glaze over that real quickly. But just to mention, there's a variety of different memory types. There's a summary memory that I talked about, summary buffer memory as well. You can have a window there. Vector store back memories, and there's also graph-based memories. So depending on exactly what you're trying to do and how much you want to be able to do some sort of a semantic search on the memory itself, you can use some sort of a graph memory as well. Before we move on, any other questions? Chris.
Yeah, is there something, some scenario that is particularly good for using entity memories for versus some other type of memory? How do we think about that?
I'm sure there are some use cases where it would be cool to have some sort of entity recognition. I can't think of one, but I still think it's kind of cool that it's able to do that. Yeah, nothing comes to mind, but I still think it's super cool. Other questions?
So when you start asking questions about what people are doing or how they're using the tools, I guess it makes me think of like when you go to a website and it asks you, do you want to save your cookies and all that kind of stuff, like you're kind of tracking them and all that. I mean, it seems like there's potential issues there when we start, keeping information, but I know that there's a buffer, so it eventually gets cleared anyway, but is that something that they've developed any kind of standard way of kind of handling that, or?
So in terms of that, one thing I will say that all of this memory is being stored entirely locally. It's not going anywhere. Your chat model only has that memory because you're passing it in as part of the prompt. You're not passing it in as a file that it's storing. So it's the same thing as, just having a conversation on ChatGPT. But yeah, the actual memory object is completely local. So it goes away once you kind of shut Jupyter Notebook. So in that way, that's kind of nice. But yeah, definitely I can see issues coming with it, but that kind of comes along with all of ChatGPT.
Right, right. Okay. Thank you.
All right. I'll quickly get started with indexes. We'll see how far we get along. It's not particularly complicated. So let's see how far we can get. So indexes are the next big thing in LangChain, and it essentially refers to the way we can structure documents so LLMs can interact with them. There again, most common way to interact with them is using chains in some sort of a retrieval step. And this basically refers to taking in a query and returning the most relevant documents and then asking questions off of that specific document. So there are 4 concepts to keep in mind. So there are document loaders because you want to be able to load your document onto wherever you want to load it. You want to be able to split that text so that the model can actually deal with it, because it can't, obviously, because of context length issues, it can't deal with a 1,000-word article, but it can deal with it in chunks. That also allows it to do some sort of better semantic search on it. And then, of course, there's the vector store where you actually store that vectorized representation of all of your information. And then finally, there are retrievers that do some sort of semantic search, and you can define what kind of semantic search as well. And you can use those to get exactly the parts of your documents that are most relevant and then give only that to your large language model, rather than giving the entire document to your large language model, which eats up a lot of context. So one of the most useful document loaders will be a PDF loader. And here we use PyPDF, and we can load any computer readable PDF. Please note that this does not use OCR, so it definitely needs to be something that is computer readable. All it's doing is it's just kind of converting all of that to text. And pretty simple. What I'm going to do here first is just import the PyPDF loader, and then download a couple of files. So these are some files on immunology and a paper on antibodies. And so essentially what this has done is it's saved those to a papers folder in your subdirectory. And so I can set my loader and I can say PyPDF loader and I give it the directory. And I want it to load specifically that philosophy of immunology PDF that I just downloaded. And so essentially what I'm doing is I'm loading that object in, and then I'm telling the loader to load and split. Essentially, it's breaking it up page by page. And I can look at the first page that, okay, the first page has this information on it. So now that document is loaded, but it's still in text form. We can also load the PDFs from a whole directory. Say I wanted to deal with multiple documents, I can use the PyPDF directory loader instead. Similar to before, instead of giving it the name of a file, I just give it the name of a directory, and then I can load that, and I just need to do loader.load, and it essentially loads those in as individual documents as well and splits them up. You can also load a Hugging Face dataset, which is super cool. So you'd use the Hugging Face dataset loader. You'd just give it the name of your dataset. You'd give it whichever page content column you need and a name. This again, all of these parameters will differ based on what the parameters are for that specific dataset. But it's pretty simple to load that dataset. You essentially call the Hugging Face dataset loader. You give it the dataset name, the page content, and other parameters, and it'll download the entire dataset for you. And then you're able to look at that dataset as well. And then this is just a quick example of, how you can use the vector store index creator. So this is, we saw this yesterday, but essentially this breaks down all of those steps, starting from document, embedding, the creating the vector store and creating the retriever. It does all of that in one simple step. The only issue with it is that it's not very dynamic. It does very simple things, but essentially I can import that vector store. I can create the vector store from the loader that I just created up here with the Hugging Face dataset. I can give it my query. What are the most used hashtags from this Twitter dataset? And I can index that query and it'll give me a result saying the most used hashtags in this context are sustainability. I don't know why the other ones are there. But yeah, questions about data loaders. Right. 4 minutes, we can do text splitters. So when you want to deal with long pieces of text, you have to split them up just so that your models can actually deal with them. But there is a lot of complexity here because you don't want to necessarily split them up at a token level. You also don't want to split them up randomly. You want to be able to keep semantically related pieces of text together. And semantically related would mean something like a sentence or a paragraph. But just generally something that you want to keep together. At a high level, they work by splitting the text up into small, meaningful chunks, and then you can combine these chunks until you reach a certain size. And once you reach that size, you can kind of do some overlap if you need to. It again depends on exactly how you want to break up your text. But we'll use the State of the Union example again. So here I'm downloading the State of the Union from this year. And now here's the characters text splitter. So I'm using the character text splitter and I'm saying separate by new lines. The chunk size should be 1,000. There should be about 200 overlap between each chunk so that there's some like contextual continuity between each chunk. And the length function is just len. So that'll determine exactly how it's determining the length of each chunk. And then essentially I can run that. I can use the text splitter on the documents of State of the Union using the create documents. And essentially this is broken up. This is the State of the Union broken up into various chunks. So there'll be other chunks. So this is the first chunk where it starts with the first little bit of the State of the Union. Questions about that? All right. Vector stores are a long, complicated ordeal, so we will get back to that on Friday, but that's where we'll stop for today. Any questions on this content we've covered so far?
So when you are doing indexes, is that querying the file or the folder similar to when you would be querying the internet, for example?
Sort of. I'm not sure I fully understand your question.
So for example, like if you upload, upload those documents and you could ask questions about those, is that accurate? And is it just answering based on what's in that document, or would it also be answering based on that document plus like the model, like the general?
So that is a whole problem that exists with these models, is the issue of hallucination. So, I could ask questions off of the document, but there's very little preventing the model from using its own understanding of the topic. And that can sometimes lead to incorrect responses. There aren't many ways to ensure that the model just looks at the document itself, apart from telling it to only do that. So you can say, based off the information presented to you in the prompt, and only the information presented to you in the prompt, ask the question. So that's one way, using prompt engineering, that you can tell it to restrict its answer only to the information that's presented to it, rather than kind of using its own general knowledge. But there isn't a way to kind of cut the model off from its own kind of information. So there is always the slight risk of hallucination, but people are working on ways on getting around that. But for the most part, I haven't seen it hallucinate too much.
Yeah,
it tends to stick to it. Yeah,
and I'll put in there, just because it's easy to sort of think about as hallucination, the model doing something that it's not supposed to do. But for all of generative AI, what you're doing is you're producing the next most likely token. That's always what it will do. That is always only what it will do. So what you can do is, if you put the information in the context, then it becomes more likely that it will only be using that. And if you actually say the words using only the information above, then it's even more likely that we'll only use this. But that is all probability. Right? It's not a certainty. This is not software, right? Where it says, oh, I'm pointing to this, only use this. It's all probabilities. But that's where the idea of using other agents to go and check the information that you get out might be useful. But this is brand new. This is all ongoing conversations.
When we're using directories, is there a limit to how much, how much information it would contain, or not really?
Yeah, it's unlimited. I guess if you're using Pinecone, you might get charged depending on how big your vector database is. But for things like Deep Lake, Chroma, those are free and open source, and you can put in as many documents as you want. The more documents you have, doing that semantic search and getting the right document might become increasingly more difficult. So that's just the one thing to keep in mind, but there's no limit per se to how many documents you can have in your document store.
The only limit would be like how much the model can take in as context. So if you have something that, needs a lot of the document store as your context, then you may run out of that.
Right. And some of the retrievers will also allow you to set a maximum length of context that it pulls from the document. So you can say, I only want 5 articles and I don't want more than X many tokens worth of information pulled from the retriever. So you can limit that there as well. But again, you might lose out on information there.
So I suggest we move into to office hours then.
Yep.
Miranda and Umang, thank you very much. Thank you. Stick around if you have questions for office hours.
So just on the same line, so so the documents, the directory that you are I guess allocating, is that whole directory taken as the context length? I didn't quite understand that. So how does it does it just pull from the relevant sources automatically, or
right?
how?
So let me share my screen real quick again, and I'll break it down a little bit better. So essentially, it happens in 4 steps, right? So the document loader loads your document into, essentially it makes it in, puts your document into readable format. Then the text splitter breaks that down into chunks that are usable. The vector stores convert those into embeddings and puts all of those documents into one sort of large semantic space, right? And then the retriever part is what controls what goes into the context of the model. The retriever, you can, based on its settings, it does some sort of a semantic search. It could be maximum marginal relevance. It could be a variety of different things. So let me quickly take a look. Yeah, so for example, right here, we're looking at a retriever. As default, I think it does, I don't know what it does by default, but you could tell it to do a maximum marginal relevance retrieval. You could do a similarities score threshold. So depending on how you set up the retriever, it'll determine how many documents it pulls into the context and what it pulls into the context. But it is doing a semantic search and all of that on the entire vector database. So not everything from the vector database comes into the context. Only the stuff that is relevant comes into the context. Joshua.
Yeah, thanks. I had a question. When we're sticking custom data into the context using retriever or any of those mechanisms, one of the limitations is the context length. And documents like CSV or JSON are super, super verbose, and they sometimes compress like 15 or 20x. But when we stick it into the model, we need to stick in the verbose version. Is there any way to compress that or do something? Because we're penalized, like for instance, if we have long variable names in the JSON, all of a sudden we're paying multiple tokens for that.
Right.
Yeah, so that's my question.
I think there is a vector store that is specifically designed for databases, which has its own ways of dealing with that. In general, even if you're not using a vector database, I've seen that these models tend to do well if you only give them like some examples. So like, the first 10 rows of data is enough for it to have a fairly good understanding of what the entire CSV file looks like. Of course, if you're doing something like stuff with anomalies, it wouldn't do that very well. But there is, from what I remember, there is a vector store that's designed specifically to deal with CSV files. I'm trying to see what it was. Yeah, I cannot find it right now, but I think there is a way that they kind of deal with it in a different way. I haven't really used that much.
Okay, great, thanks.
Yes, Raymond.
Yeah.
I was just curious if there's a way to set a parameter to artificially cap the number of tokens that we'll use within a 4K token set or however many tokens set.
I have definitely come across that. I think you can either set that in a chain or where you call the model itself. Miranda, do you remember where you might have seen that? I definitely remember seeing that you are able to cap it somewhere.
Yeah, I've seen it, but I think it depends on the model. So you'd have to really take a look at the API reference to see like what it takes as an argument. Yeah, but I have seen it. I just don't know exactly much about using
well, to refine it a bit, do you know if there's anything like a plugin for GPT 3.5?
I think the plugins are only available for 4.
Yeah, I'm working with basically trying to min-max them anyway. And then also I'm kind of, one of the reasons I started off with 3.5, it was working with it before, is just, it's useful for me personally to kind of see exactly how much productivity I can cram into limited resource parameters. That way, if I can get, the best bang for my buck out of that, I can extrapolate. So it's like, okay, if I can get this much done with 4K tokens, then I can run calculations on how many more I could with 100K like that.
Right.
All right, thank you.
Janet.
Hi. Yeah, I was kind of going back to what Holly was saying with not being able to use certain data. And I'm wondering if there's a way to say don't use information from this website. Not only that, don't use because their product is in conflict with what I'm trying to say, don't use any references that they've sponsored. Maybe, and I'm thinking of, I'm going to do an example because I don't, it might be easier to explain. So if I'm writing a paper on, say, the problems with, sugar, drinking a bunch of sugar and sodas or something like that, can I say, okay, don't use anything from the Coca-Cola website, and don't use any studies that have been done that have been sponsored by Coca-Cola. Mm-hmm. I mean, can you do something like that? I just don't know.
Yeah, probably. It would kind of go into a little bit of the example selectors, output parsing, into the prompt itself, telling it, kind of instructing it to do something or not do something, and then connect it to the internet using something like the like a Google search API. Miranda, what do you think?
Instructions for the output parser or for the examples. And I'm going to turn my camera off because it's saying my internet is weird. But I would say that you could put that, where it says the source should be a website. You could also add to that, as much as you want. The source should be a website or a paper that is not sponsored by Coca-Cola. The trick there is, I know that sometimes they try to hide that a lot. So depending on how well that's hidden, the model may do a better or worse job of identifying papers that are sponsored by Coca-Cola. The other thing that I was going to say, though, is when we get into tools and agents, you can give it the tools and it will only use those tools to answer the question. So there's a tool for archive papers. There's a tool for, you can make custom tools if there's a specific publication that you want to go through. And with those tools, it's easier to restrict kind of what it's doing. But those are.
Yep. Does that sort of answer your question, Janet?
Yeah, I think so. I just don't want to limit it. I want to keep it as open as possible, but I just want to say, I guess it's just the don't use. I think it's more, it might be better to use the don't use this information rather than limit the information only to a specific.
Right. You could also instruct it to perhaps do like a, say, gets information from a source. You could instruct it to verify the source's source. Like if it was, you can do that in agents, sort of like along the lines of chain of thought reasoning. I have got this information. I know what its source is. Now I'm going to go look at, who sponsored this result. So you could kind of get it to do that verification in sort of a loop and ensure that, it only presents you with, and I've seen AutoGPT do stuff like that. It kind of thinks through it, and it decides, what my next task is and what my list of tasks is, and then goes down the list, and then it goes down it again, depending on what its output was. So you'll see a little bit of that when we talk about agents on Friday. But I think the use of an agent along with the Google Search APIs and good prompt engineering will get you most of the way there.
And even if you don't vet what's there, you can provide additional context. Like you can imagine almost like a footnote of saying, I cited this website. Here's an assessment of the website, and so it can be more information about where it came from. So, because if it's a website which is considered, which, appears to not be a news outlet, but appears to be, something which, so you can think of questions that you might run separately against it to answer questions about the source. And so you could at least say, I got the answer from here. Here's a whole bunch of information about the site. So the reader then has to judge and say, all right, at least I know where you got the information from, and here's a quick assessment of the source of the information.
Yeah, I wonder if at some point, these data sets are so large, and will it just eventually not matter? It doesn't matter, whether things are correct or incorrect. It's just all data. It's the same thing like, with how much information they're, gathering from, just from the internet, from our personal information. At some point we were very protective over that stuff. And now it's like, well, it kind of almost doesn't matter. Everybody's got everything. So I don't know. It's just something to think about.
And the difference here is that now we can do something with the information, right? So now it may be a lot of information, but you can actually come up with a criterion or a rubric or some policy against which you want to judge this, right? And we couldn't really do that before. So before it was just a flood of information and there wasn't anything that we could do. You can have a policy where you might go back and flag in any information if it's not in some is a list of known webs of known, vetted websites could, or, if it contains other information, that indicates that it's not a reliable, I can't even, think of all the possibilities, but you can structure this information, which means we can do more with it, but then also now, all of a sudden, now we need to be more careful with our information, even though the horse may be out of the barn. It's like people can follow like the entity tracking that we were just looking at.
Right.
Well, that means that the models can track entities and sort of figure out your relationships to other people in an automated way that we couldn't do before. So it's both.
Yeah. Okay, thanks.
I had a similar question as Janet was, as Janet's question. So if, for example, like I'm assuming with the agents, it would be impossible to restrict the search to something like PubMed, for example. And if we do that, like for example, some of the papers would just be in the form of a PDF, and would it be actually able to pull it from that, or is that does it actually have to be like an online format?
It depends entirely on how that tool or agent is set up, and it depends on how much access that API gives you. For example, there is a tool for archive papers, and there's also a tool for Wikipedia. So it depends on how much access that Wikipedia or archive API is giving you. So if that API allows you to like get PDFs and source PDFs from their website, sure. But if the tool or if the API is more restrictive and only allows access to certain number of articles or certain years of publications or something. And I've seen that a lot. There's, for example, the Twitter API is now just a nightmare. There's no way to get around it. It depends entirely on the way that information is being accessed using that tool, and if it is using an API, the limitations of that API itself.
I'm assuming we could use our password to access to these like the PubMed articles.
Yes.
Well, and it wouldn't be password though. You really would have to have an API.
Right. Yeah. It needs some sort of credential.
Yeah.
Yeah. It would need to. Yeah.
I meant like the credentials, for example, like the Vanderbilt credentials. Are you able to use that? Like otherwise the PubMed would be, the ones open sourced would be very restricted.
Yeah,
I would say yes, but
yeah,
not
library is working on this, right? So Mong, we've been talking to the new head librarian, John Shaw, and this is something that is sort of going to be their area. Like, how do we access with LangChain and with these brand new tools these resources? So they're definitely aware of it and they're working toward it. And sometimes it'll be an easy solution, but sometimes it may require some work. What do you think, Iman?
Yeah, totally. And I've seen people do some crazy stuff with AutoGPT. Like they put their passwords or credentials in some sort of a text file that AutoGPT has access to, and AutoGPT can go and do things for them.
Yeah.
You know, order me Domino's pizza. And I saw someone do that, and that was incredible because it had their credit card information, it had their address, it had their Domino's login. It wasn't easy for them to
do. Not a good idea.
No, terrible idea. Terrible idea. Don't do this. But
although I appreciated the free pizza.
but yeah, you can do it. It's just not advisable because all of this isn't necessarily behind any sort of firewall. There's no guarantee that your password isn't, being put into nefarious websites by AutoGPT. Maybe it went to dominoes.ru instead of dominoes.com, and now suddenly a Russian website has your password. So it not advisable, but anything is possible. Brian, if we have a hand up next.
So this kind of ties into everything that we've been talking about, which seems, how can this be used now? It seems like, especially with so much of this entire world is changing so quickly and growing so quickly. And I mean, even how we saw with LangChain, they did the update yesterday and it broke things. And it's like, how are you going to really use this in a real world scenario? It seems like it's super helpful, but with just how quickly it's changing and the fact that it's open source, and as we were seeing with the different responses, sometimes they're adding the new line character, sometimes they're not, and each little piece may be slightly different. And also, as has been mentioned a number of times, the idea of you have to use the APIs and go out to external resources. And it just seems like actually using this in the immediate future in the real world isn't possible. It seems like it's going to be, so understand it, know what's going on, but just so I'm curious to hear your responses on that.
I mean, it's definitely possible to use right now. Most updates are not breaking changes updates. It's something that comes with using something that is being actively developed. It's only released a couple months ago. So asking how you can use it right now is not beneficial if you want to develop an application that you can use in a year. And, that's hard with code anyway, to develop an application that you could use in a year and make sure that you update it and stuff. So it's just one of those things that, and, maybe this will, because they're coming out with new tools all the time, like GitHub Copilot and GitHub Copilot X, where you can put in the documentation for a code base and say, oh, look at this change. They updated it. Now update my code to reflect the changes. Exactly. So, you know, it's changing, yes, but it's kind of just the way of the world now. So I don't know what to tell you about, like, it's frustrating. Yeah, but it's kind of just how it is.
Yeah, and another more rudimentary way of dealing with it would be, so for example, the Hugging Face LangChain assistant that we had that broke. What I did this time after fixing the code was in my requirements file where I load all the packages, I specified a LangChain version. So it will only always download that LangChain version. So for me, for this specific application, unless I lose like API support down the line for something like Deep Lake that I'm using, it won't break for the most part. So in the short term, it's you can find ways to deal with it, but yeah, at some point you're going to want to update your code base. Holly.
Yep. Oh, you're still unmuted, Holly.
How many times do we say that, even though we rule well practiced now? But yeah, could you tell me more about AutoGPT and how it's different than LangChain?
AutoGPT is sort of built along the same concepts of LangChain. You can also access AutoGPT through LangChain, but essentially what it is it's an agent. It's an agent on steroids, which has access to a lot of things. And a lot of the different modules that we've talked about. It has a memory, it has a vector store, and it's I don't exactly know how AutoGPT works, but it's in essence, it is an agent that's able to do a lot of different things and has a lot of free reign as to what services it can and can't use.
It was developed almost in parallel with LangChain. And so a lot of the things that we're learning about in LangChain, it was built sort of as a single monolithic solution. You can implement the idea behind AutoGPT in LangChain. So it just breaks it up into larger, more modular parts, whereas this is like a single, and it's very cool what it was able to do. But to update it, you need to like update that single big code base. So what they did was they re-implemented AutoGPT in LangChain. And there are other approaches too. AutoGPT is not the only one. There's Baby AGI, there's multi-agent, there's a whole bunch. And they all are working with the idea of you have a single agent and then you have a criterion that you're trying to meet, or you have multiple agents that communicate in a certain way with a certain policy. Or you have this kind of memory or that kind of memory, but all around automating a process until it meets a criteria or policy or something along those lines.
Got it. And then the other question I had, because I I'm not entirely sure what I was saying, but I felt like the person who was showing me some work in AutoGPT was actually having it go out to live web pages.
Oh yeah.
Could you help me understand? Because when you're saying LangChain couldn't really do that, is it because we were using ChatGPT?
Yeah.
Okay.
So LangChain actually can absolutely get to. There are all sorts of tools that you have access to in LangChain that could go to live websites. It could go to other services, and same thing with AutoGPT, and also to sort of put in the mix there that idea of automating that, going out, getting information and putting it into the context, because that's a lot of what's going on, putting it back in the context. That's what plugins do too. Like the OpenAI plugins, it's just a sort of it's a shorter path. Whereas with LangChain, it's kind of like interpret and then go do this and then explicitly rerun that prompt with this additional information put in. Plugins from OpenAI sort of do that underneath the covers, right? Where you can't really see it. But they're doing the same thing. Go out, find some things according to some criteria, bring it back into the context, rerun.
So my final question, I don't want to take up everybody's time, but is this how somebody who would want to create their own baby GPT, they would do it through something like LangChain or OpenGPT?
And by baby AGI or baby, what do you mean by baby GPT?
They want to create their own baby, I guess, baby AI.
Yes. Oh, absolutely. Yeah. Okay. And there's a nice series of tutorials on this as well, of how do you build your own baby AGI or your own AutoGPT in LangChain, and then you can change what the policies are. You can change what the tools are that are available to it. You can, and by the way, this is absolutely how I'm thinking that we make your game, your role playing happen. I think that kind of
is if we just avoid ChatGPT and then we do some AutoGPT. That's what I was wondering too, as I've been listening.
Exactly. All the memory and the state and the entity tracking and all that stuff. Yeah.
Janet.
Yeah, this is kind of out there maybe. So like there are a couple questions in this. So would it be a good place like on the internet, if you have, the plugins on the top right side of your, Internet Explorer, if you, or whatever you're using, Chrome. So instead of a plugin, like, could you have like an API locker, like as in like, and make it blockchain as in like a MetaMask for cryptocurrencies, where you would be able to load your keys to your APIs, because I want to use these APIs, and here are my keychains to say that I have access to it. I have access to the Vanderbilt, library of whatever. So I'm wondering if maybe there's a way somehow that way to use it. And the reason why I was asking it, one of my original questions was, I understand, we're trying to limit the number of tokens that we're using. However, in blockchain, in cryptocurrency, how are those tokens? I mean, you're buying tokens to make these transactions and building them on top of each other to create these blockchains that are all interconnected. So like, how are those two tokens? They're different, right?
Yeah, very, very different. Yeah, same
Okay.
word, but just like a good transformer does, depending on the context, it takes on very different meaning. So token in this sense is just referring to a word or subword. That's it.
Okay.
Yeah. So when we say how many tokens you have, it's like, okay, depending on your tokenization scheme, how many tokens does it take to represent the text that you have?
But they seem they seem to have value.
Well,
value as in currency, because everyone's talking about, oh my gosh, does this take up tokens?
But it's almost like space, like how, and it really is just a count of how many words. And it's the way that the services sort of count how much, if they do limiting, they charge you by the token. So if they charge you, I'm going to charge you 0.001 cent to process each token that you send me. So that's one way that it costs. No air quotes. That's one way that it costs. Another way that it costs, air quotes, is you only have 4,000 tokens that you can have in the context that the model will be aware of, and that can work with all at once to answer your questions and to do your work. So in that case, you don't want to take up a whole bunch of it with extraneous information. You want to have as valuable information in there so you're using your context wisely.
Right.
Yeah. But that's not fungible, right?
No.
Right? You can't sort of give your tokens to somebody else like you can with a blockchain, perhaps, right? Or some type of cryptocurrency. This is like, think of it more like a limit. This is just what you have.
Right. I mean, yeah. I mean, what if you could share, just say, hey, can we pull all these people? If everybody has 4,000 tokens, can we pull all those together? You can't do that.
But the token limit is at the model level. But you could do it at the level of spending with the service, maybe. It's like, okay, and that might be like an institutional license where you have all these. So that'd be one way of sort of sharing, but you can't share context length, because that is a hard limit of computational limit of the model. That's how it was built. Once you build it with a certain context length, that's what that model will have forevermore.
And then on sharing those APIs, like, you know, having an API kind of locker or something,
yeah.
I don't know how, like, can you do, because you know, if I want to share my API with only a certain number of people, I don't know if that works.
It makes me think a little bit, Umang, Charo, or Miranda, about secrets. You know how GitHub has secrets? It's almost like that, right? You can share your token, or I'm sorry, you can share your API key, let's call it a key just to separate it out, with a set number without letting them ever know what it is.
Yeah, as far as like if that exists, I don't know of one that exists, but it'd be nice. I use a password manager, yeah.
Yeah, password. So Charo, is that the same thing as secrets, or Charo or Umang?
Yeah, so GitHub does have the ability to, where like in an organization, you can save your secrets for your organization and then you just reference it. So just exactly like Jesse was saying, you give it a name and like anyone in the organization can reference it, but only the secrets file that only administrative people can access can actually see the key.
Got it. Oh, I like that.
Invalidate it, whatever you need to do. Also, Umang implemented something during DSSG last year where Umang, it was like only certain people could access certain students' files, and you did that with like a whitelist or something like that. I think that's like the inverse sort of, but access through AWS.
That was on AWS, yeah.
So that could be another way. I don't know, enumerate the people who have access to this particular thing, but that would be a lot of writing. So.
All right, well, thanks. Just wanted to get your insight on that.
Brian.
So I keep going back to the validating the responses that you're getting from models. And especially with LangChain, it seems like if you're asking for code, that seems pretty easy to validate. All you do is take the response, save it into a file, run a command line, hey, make sure this runs, and then you can obviously ask for test cases. So then you can say, run it with these test cases. Okay, I got this error. Well, we're still in our code. So we then go back to that conversation and say, hey, I got this error when I ran that code, correct it. And then you get a new chunk of code. Then you say, okay, let me run that. Okay, that worked. And you could even do things like use best practices. Is this the most efficient? Different things like that. And there's ways of validating the code like that, which is great. But what about when you're not talking about code? When you're asking, what's the capital of France? And it kind of goes back to, again, all of this, which is, it's not, like you said numerous times, this isn't software. It's not going to give you an exact answer. And one way to do it is obviously ask multiple times, see what the responses are, and then compare them to make sure and take the average or best, most likely one that comes back.
Yeah, but you have multiple agents. Think of multiple agents, right? And the different things you can do. So let's say that you have a document store and you're answering questions off of a document store. So you could ask it with the generative AI and it gives you an answer which sort of is in a sentence and, you know, consumable, right? But you can also run a totally different type of a model, transformer model, that's not generative AI, that does extractive question answering. And so all it does is it goes through using a much simpler model, like a BERT model, goes through, see if it can extract the answer to the question. And then you compare the two and you see how close it is. So that's a totally different, you know, it's not 100%, but you're validating using a different model, you know, and you can imagine explicitly going to other websites or having another agent with a different prompt answering the question. So you're not always just stuck with this one model and trying to figure out with this one model. You can go outside of that.
And I'm just trying to think of, especially with LangChain, that seems to be a huge part of this, where you can, in one notebook or Python file or whatever you want to do, you can go out to those different places. It seems like a great way of, like you said, instead of it being like this, you can really open it up and pull all these pieces together and do that validation and that checking. So yeah, it's very, very interesting to see this particular piece. And then with all the changes, like when Umang was going over the text splitting, I mean, that immediately I was thinking of narrative art and the time that Yuning spent to split the word windows. And I believe that LangChain doesn't currently work with Distilbert. I'm not positive about that.
It does not.
It
no.
could. Not Distilbert. It doesn't work with local.
It might work with local, but if you're using the Hugging Face hub and like streaming information from a model, it seems to only support large language models right now.
Oh, for with the easy sort of Hugging Face, yeah.
Right.
Which is not.
You might be able to go the download approach and see, because it let me download Bloom as text generation, so I wonder if I can download Bloom as some other. Yeah. It seems
maybe only generative models. It was really built around generative models.
It did say in the documentation that this is a work in progress, so we'll see.
But it is open source, and those agents, I mean, because you would just be building completely your own, but that's not a terrible thing. I mean, they're already, there's not going to be these high level abstractions for like all the different types of transformer models that you can have. But you could build your own and then wrap that up as an agent or as a tool, and for that LangChain would not access.
Yeah. Yeah. The other thing I was thinking is, could you use pieces of LangChain outside of LangChain? So like the text splitting or the vector spaces. Now I understand that's all in LangChain, but
why
if
not?
you could export it out to just a regular thing, like whether it's a Hugging Face, like whatever you're trying to do, would be cool if you could take some of that functionality that LangChain has and use it outside of it. I get the idea of you can wrap things inside of LangChain to stay in that ecosphere, but if you could pull stuff out, that'd be cool too.
Yeah, I mean, all of what LangChain is doing is a wrapper around things that already exist.
Yeah.
So it will return you an object that you can, convert to whatever you need or save to a file, or, even if it's a class that is only existing within LangChain, you can, I'm sure, do some coding magic to convert it to, something. At least that's my thought on it.
No. Cool.
Chris.
Yeah, I guess if I want to have a conversational chat about data stored in a database, is there a recommended model within the Hugging Face pipeline that is a good fit, or any model outside it that you would recommend if I want to run everything purely locally?
Are you looking for are you looking to sort of hit on a structured? Are you trying to keep it like in a database, or?
Yeah. This is for querying structured data in massive databases that I already have. So if I, as an example, let's say that there is a students table that has every piece of information on students. Like I want to be able to say, tell me students, how many students do we have from this ethnic group this year compared to 5 years ago?
Yeah.
And I want,
that's more in the realm of AI assisted coding, where the model is aware of the data structures that you have. And that works really well, right? So you don't need LangChain for that necessarily. That would be, I have 5 tables. Here are my schema, right? Answer the following questions. And then it generates SQL code for you.
Yeah, I guess the thing is I don't want it to generate SQL code. I want it to then query the database, just give me the result. Because what I'm trying to do is allow others to query the data, like non-technical people to query the data through natural language.
So you can build an agent, that would take your query, generate the SQL code, run the SQL code, return it in the context, so you could then answer the questions.
Right. Well, there are also chains for that too,
Yeah,
for querying a SQL database or querying, whatever database you want. Yeah. As far as like the model that you choose that's not where, I don't think that's where you're going to get the functionality to do that. It's in the chain itself. So as far as what model to use on Hugging Face is kind of like, what's the best model on Hugging Face?
Yeah.
I'll also say, I think the way Jesse is describing it, how to approach it is a really good way, because so there are a table question answering a table question on Hugging Face, but it is questionable how good they are currently, especially against something like GPT-4, where you just, as Jesse said, you would like give it the table. And also like with those table question answering models, you generally have to convert them to some other format. Like everything is like a string, and that is going to take a long time anyways. And also you would still have to use it in a chain, because it sounds like you would almost have to like kind of prompt it like in that chain of thought kind of fashion that Umang talked about earlier. So I think Jesse's way is the way to go.
Yeah, or you could, they have this. So there's a SQL chain, specifically a SQL database chain, where if you have a SQL database, I guess this is living on a Chinook database somewhere, and you give it an LLM, you can literally just ask how many employees are there.
Yeah.
It does it. It runs the SQL query, doing some SQL alchemy stuff, and it gives you the answer. So it'll work, but you will likely have to rely on some OpenAI model. I don't know of a Hugging Face model that would do this well. But this will definitely work for exactly what you're trying to do.
Got it. And if I have Llama running locally, can I use that with LangChain?
I think so. I'm sure you can. I'll need to look at it, but I'm sure you can.
Got it. Yeah, I guess I'm just trying to see how can I get this up and running as quickly and easily as possible without sending any data over the wire to some other external service.
Is it Open Llama from Hugging Face?
I'm not using anything at the moment. I guess it's more of a question on what I should use.
I think, I see what you're saying. I think Umang is right. I think you could probably use a local model. Just in looking at the Hugging Face hub thing that you showed, how it like loads that. The regular Hugging Face should be able to load as well, because it's just like some folder on your computer. So I think if you tried like Open Llama, and you can have that running on your computer, as long as you can reference that model as you're trying to create your agent or whatever from it, then you should be set.
Got it. Thank you.
But that is Llama, right? So it's only instruction fine-tuning, right?
Yeah.
Okay.
And when you say Open Llama, is this what Facebook has officially released, or is this leaked?
No, so they released the Llama architecture. The weights leaked, but they were not licensing the weights broadly. But then you have other people who have taken the architecture and done additional training. And another one which is coming out is the Red Pajama, which is going to also be open source weights and the Llama architecture. Some of that initial training is already done, and the rest of it should be done soon. And that's going to be very liberal license. So there are a number of different varieties of Llama-based solutions that are out there, some of which are just the language, some of which have instruction fine-tuning, pretty well done, and then others which are going to have some reinforcement learning from human feedback to make it more chat-like as well. And you'll be seeing more and more of these coming up the next couple of weeks.
Got it. So I guess if I want to do something that's completely above board and
Red Pajamas is a great way to go. It's like completely open for academic use and commercial use.
Got it. Thanks. Oh, but it's not out yet. You're saying
some of them are, like the 7 billion and 13 billion parameter one's out, and I think they're instruction fine-tuned. But they were working on it over the summer. So,
and I think Hugging Face just released the Open Llama.
The Open Llama, right? And I don't know as much about. And you said that was instruction fine-tuned already, Charlotte?
I got to check.
Yeah. So you have these different you have the architecture, and then you have the different trainings of the different training sets. And part of it, you just have to assess how well it works for your particular use case as well. You have to try it. It's best if you can come up with a metric of a known type of performance you want to have, and then you can assess the models, because you're going to have a lot of choices.
Got it. Thank you.
And you could use LangChain to iterate through that.
Yes. Great. Other questions? Yeah, Chris.
Sorry, I'll let Janet go ahead first.
Yeah.
Oh, well, I'm interested in what Chris is doing, because that's kind of the same thing. I've got databases that I want other people to use, but my thought process, and I might now have misunderstood. So if I'm trying to have them use my database, I thought that was like run through an API. That's not?
That is one way.
Okay.
But this opens up like brand new ways, right? Of sharing what you want to. Who are you? Do you have knowledgeable users that would be able to write their own SQL, or are you trying to get like question answering?
They need to question and answering more. They're going to input information, and based off of that input, it's going to run through my databases. But all that stuff, my thought was that that database information would be stored in one API that would run through it constantly. So I would be able to give them, that would be kind of their login, because they would say, okay, I would give them access to that API. So
what would their request look like? Like what would an interaction look like?
They would plug in their address of their project, of where their project is. And, I guess out would come, different information, I don't know, out would come different information like based off of that address and the functionality of the building and things like that. I'm doing structural engineering, so so it would give classification codes. It would say what would be the ruling load cases. And then based off of all that information, I would be able to they would then be able to say, okay, here's the information that I need out. And I would say, okay, well, here it all is. And that would be going to my databases and looking up multitudes of information on multi-code books based off of the address of where they're located. If they're located in Florida, they're looking at the Florida building code. And if they're, in Tennessee, they're looking at the Tennessee building code. But all of them are all referencing the same information from ASC 7, IBC, things like that. So they're all referencing, there's general, and then it just gets smaller and smaller. And then it's like, okay, just for, Franklin County, these are very code specific information just for that county.
Yeah. It sounded like multiple agents to me, right? And so one would be, an overview, like, okay, you put in your address, and then it tells you sort of high level information, and then gives you suggestions about how they might be able to ask for additional information. When they ask for additional information, then that might kick off another agent that would go off and then, search for, geographic specific. So I think the way to do this is to come up with sample interactions and think along the lines of what an agent would do. So if you had, a team of interns, behind what it would look like. How many, do you have like one intern that sort of knows how to greet them and like give them a quick rundown, like a quick early lookup of information about them? But you might have another one that is a specialist in codes for Florida, right? Because it may be different. You don't do hurricane, that's not even a thing, in the Midwest. So you might have a specialized agent, and the specialized agent is look in these areas with special attention to, return in the following format, right? But that would be a totally separate agent, but it would start with, an overview. You can ask the following questions. And when they ask the questions, however they ask them, then the model would realize you'd have a tool or an agent that would say, oh, I need to go off and do my thing because they're asking about something in Florida. Therefore, I'm going to return information. Does that kind of make sense?
Yeah, and I agree with that. I think that makes sense. So it's referencing information off of either from my database and maybe from some verbiage, textbooks. So like, and I just still don't understand. Like, so are they accessing it through my API? Are they accessing it?
I think you would have to have, well, it depends on how you want to do it, right? If you want this to be a service, a pay for service, then they would be sending you information. You'd be running everything. If instead you want to make it like an open source, like a tool that you can make available, then you could do that. And then you can make it more generally available. So it really depends on you and how you would like to do it. So if they ask questions, and if they're a client of yours, you don't want them to have to go and get all the API keys and to make sure that they have access to that. You would sort of own that right?
Well, there's a part. So I want to make it open sourced for other engineers so that the engineer who's in the Midwest or whatever, who's in Colorado and knows all about snow loads, or the engineer who's knowledgeable about seismic in California, I want them to be able to load information into this system just as easily as I can.
Got it.
But the customer is going to need to, somehow pay for the information. And I don't know how.
So is your question more, how are people accessing your database, or how are people accessing the model? Because I think those are two separate issues.
That's what I thought was all in one if I turned it into an API. Is that not?
No. So okay. I think what the confusion is you set up a database that can be through, you can host it locally on your machine. It has to live somewhere. If you do some of the examples we looked at today, we just made the database on our, Colab instance. You could also have a database that is on a local machine that you pay to make available to people. On a server that you pay to make available to people, or you could store it in something like Deep Lake that has, you can access a database from its like ID or something. And in this case, if you have this application running somewhere, it's already accessing that database. So people aren't needing to like log in and stuff because it already has access to the database. It's kind of just like how you choose to make your application available, like the UI itself. So are people, if you're envisioning people go to a website, www.myapplication.com and using that there, or are you expecting them to download all of your source code and then run it locally themselves? So those are kind of the considerations. So the database is separate from the LangChain and model API things.
It's just referencing it can pull from those databases if I ask it to.
Yeah, you're kind of just giving it like the ability to look at your database.
Okay. All right. Thank you. I know it's just kind of nebulous for me. So thank you.
Oh yeah, no problem. I hope that made sense.
It does.
Looks like we're at the end of our time. Any final questions? All right. Great. See you all on Friday.
All right. Thank you.